For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, looks like we are live. I get a kick out of that thumbnail. So we're live. SFT, late night with SFT, I should say. I knew I wouldn't be able to keep keep a straight face with that one. Good to see everybody in the chat. Guys, we've had a busy night. We've had Doki Doki already with the super stickers. Doki, you're the super Doki, you've got at least 5 PhDs in super stickers. George Bond says, beautiful piano. Yes, I can't say that that's me playing it, though. So good to see everybody. Luca just woke up. Hope you slept like an angel, Luca. Dessel, good to see you. And yeah, good to see everybody. Doki Doki, of course. So Nightmare, good to see you. This is going to be a lot of fun tonight. Gutsick Gibbon still doesn't understand genetic diversity. And tomorrow night, though, we are going to be doing Gutsick Gibbon really doesn't understand radioactive decay. So that's going to be a lot of fun. We at Team SFT, we got some good information as well from Scott Devlin right here. I'm screen sharing. Actually, I may have to remove this picture real quick so you guys can see. Let's see here. Boom. Okay. Scott Devlin gave us some good feedback on the portion of Erica's video on radioactive decay. So he's got a degree in geophysics. He works for CMI. So he's been a blessing right here. Degree in geophysics from the University of Leeds. He's worked in civil engineering, oil and gas, medical device industries. He's definitely qualified to talk about that topic. So also, though, please go check out our David McQueen interview and on economic geology, as well as our one with Steph on oil exploration and with George. So that one was definitely one to remember. I'm pumped for this one. PhD geologist Dr. John McKay is going to be here. We're going to be discussing the amazing science that confirms the Genesis flood. Dr. Lyle on Wednesday, he'll be here talking about evidence for young biblical creation. We're going to get into distant starlight. We're going to have him address the most common objections to Dr. Lyle's model. So we're looking forward to that one. And I got to say, Team Dodgeball, it's not looking too good for him. Dodge, duck, dip, dive, and dodge. There's the 5 Ds right there. And this video we're about to do, I'm going to be playing, I think it's a couple-minute clip from Erica's latest video on the genetic diversity in humans and animals that she failed on pretty bad. So we're going to showcase that tonight. I'm going to show a quick little, let's share the audio here, guys. So here's what we're looking at these days with Team Dodgeball. They're ducking, they're dipping, they're diving, they're dodging all over the place. Here we go. Right here, this is Dan. I know he looks a little bit like Jim Carrey, but he dodging all the arguments, ducking all the questions. Yeah, look at them go. Yeah, oh yeah. Yeah, not looking good for them guys. So this is going to be a lot of fun tonight. Now, the portion on the genetic diversity is not going to be all that long because I have already spent a couple hours on it here. SFT versus Swamidass, where he made similar claims on genetic diversity. I spent a couple hours on that. So check that one out for more of an extensive and thorough refutation of their claims on genetic diversity in humans, animals. So I predicted in that video actually what Erica's response would be, and that was exactly what her response was. So you can't really make this stuff up. But when they read our technical literature like this, that's real-time footage of Dr. Swamidass reading Dr. Jensen's newest paper on Y chromosome prediction. So the reason why he flopped so bad, guys, could be due to the fact that he's wearing a blindfold. So Dessel Dre says, howdy to you as well. Doki Doki says, dodgeball Jim Carrey. That's right. That's exactly who that is. So they're dodging, they're ducking. $2 super chat from Doki Doki. Thank you so much, Doki Doki. Peaceful dodging. Yes. Yes. They're very peaceful in their dodging. That is for certain. They've mastered it. They mastered it. I'm telling you, it's impressive. It's impressive, their dodgeball skills. So let's see. I think that's it for announcements. Bob Enyart. We're just working at confirming a date for him. He's going to be here. He's going to give us, hopefully we're going to be talking about the hydroplate theory, going over the so-called heat problem. So we're hitting every point, addressing every word and sentence spoken by the critics, leaving no stone unturned. So anyways, today's video, okay, debunking Erica on genetic diversity from her 3.5-hour video. Now, I want to point out the fact that they're pretending like it doesn't exist, but I want you guys to check out our playlist. I'm going to screen share so you guys can see it. Right here, our playlist debunking every word spoken by her. This has been such a blast. And I got to say, guys, I am loving her damage control posts claiming that she won't be responding. You know, if I was in Team Dodgeball's shoes, I wouldn't want to respond either. And we're 100% fine with that. We've got content till at least year 3000, okay? With or without Team Dodgeball. So we've already predicted, right? They say creationists don't make future testable predictions, but guys, we already predicted that Gutsick Gibbon would be the first one to tap out, and I'll tell you why. It's because there are no answers to the countless questions we have asked that have not been answered, just dodged, just ducked, dipped, dived, and dodged all over the place. We've also now been debunking her portions on geology, oil exploration, radiometric, radioactive decay, and so on. Which, by the way, I want to point out, go have a look at them. Her damage control community posts have not even come close to addressing our latest videos on oil exploration and geology. So don't worry, guys, more to come. Starting with tomorrow, we're actually going to get through quite a bit of her video on radioactive decay. But today, actually, before I get right into her video, so right here, this is the series. Go have a look, guys. Here's the thing. I am confident enough, okay? And that's why I typically will put their videos or their responses in our description box or acknowledge, hey, this is their video. This is where you can find it, because I'm confident when you watch our series of videos and Team Dodgeball series of videos, if you watch them objectively, you will come away with knowing clearly who's dodging, who's not answering the issue. So supposedly the Dr. Joshua Swamidass portion of the 3.5-hour video was supposed to be the most difficult part to debunk. And I like to go at the hardest parts first. So I decided to start off with that. And we got a whole series addressing every word spoken in that interview, which I think was about 45 or 50 minutes long. All the genetics. This one, guys, check out this one on Mutation rates, failed attempt to debunk biblical creation, part 6 on mutation rates. The Y chromosome, oof. Oh, it's not looking good for her, that one. Dr. Dan Stern Cardinal dodges again, responding to the worst rebuttal in the history of rebuttals. That was one of my favorites to do. I was flabbergasted when I watched Dan's attempt to defend this one, dismantling Gutsick Gibbon and Joshua Swamidass. So here's the thing, guys. It's just not looking good for them. I mean, none of them are answering the questions on abiogenesis, the chicken and egg problems. Erica attempted to for a couple hours, guys. If you haven't seen our video with Erica, a 2-hour discussion in John Maddox's after show, the opportunity to address the major chicken and egg problems from chemical evolution, abiogenesis. So definitely check that out. Yeah, guys, I organize all these playlists really nicely for you guys. So definitely, if you're new to the channel, go check it out. Let me see the chat there. Yes, Caleb. Caleb, if you just got here, you might not have seen the 5 Ds of Dodge. Let's see. Let's put it up on the screen for you. They've mastered it. PhD. Dodge, duck, dip, dive, and dodge. This is what we're doing tonight. Gutsick Gibbon still doesn't understand genetic diversity. And guys, don't forget to congratulate Diaper Dino. He has officially devolved from Dapper Dino to Diaper Dino. But you know, if I was Diaper Dino, I wouldn't want to come onto our channel and debate us as well. So, yeah. Renwell asks, have we? Yes. So we've answered her questions. We've answered her challenges. She's ignored hundreds of ours. But Gutsick Gibbon's the kind of person who will ask a question, and if she doesn't get the answer that she wants, she will then say that the question hasn't been answered. Oh, I love it. Love it. So, okay. Yeah, so I showed you guys the playlist. Congratulate Diaper Dino. Let's get right into it, guys. So we are addressing her claims on genetic diversity in humans and higher levels of genetic diversity in animals. Now, I said earlier, okay, so go I've seen this video getting shared on Facebook, and people are loving it. People are loving it. So I debunked good old Joshua Swamidass on this extensively in a video it was about a month ago. And Swamidass has dodged and has refused to correct his straw man statements, which is fine. There is no answer other than admitting he was wrong. Okay. And these critics have a hard time admitting that when they're wrong. That's the problem. Now, in this video, okay, as I stated earlier, I actually predicted what Erica's response would be on this, because this is a fatal blow to their model. This is a fatal blow to their out of Africa scenario. Okay. And I'm currently writing a book on this. I'm hoping to have it done in a month, but I'm going, I'm making it as extensive, irrefutable as possible. So I've got all this stuff just sitting there in my brain, and I'm going to go through it all today, but definitely for an extremely thorough video on it, go check out this one. Okay. So I predicted that her answer, her response in her 3.5-hour video would essentially be a straw man, and as she missed the point completely, okay? She attempted to kind of rebut it. What was it, in a video maybe 4 or 5 months ago? And someone on her own side, it was emotionally stunted, corrected her on it, said, Erica, you're misunderstanding their argument. Now, then we waited another few months for a correction, and all we got, guys, was a fulfillment of my prediction. Creationists making future testable predictions. The prediction can be found in this Swamidass video. She literally used the exact argument I said she would use, which, by the way, I destroyed in the Swamidass video itself. The Swamidass video is extremely extensive and technical. So for a 2-hour video on the topic, like I said, refer to this video. We're going to spend some time on it here, of course, but because we won't be spending too much time on it, we're also going to complete our genetic entropy video from last week. It's going to be part 2. I've got part 1 in the description box, so definitely check that out, okay? So here's the thing. Erica, once again, as she frequently does, resorted to an exception to the rule as an argument and missed the entire point. This has been very evident, guys, in her 3.5-hour video response to us. Now, please, once again, as I showed earlier, check out our playlist, Debunking Her, especially on the portions that were supposed to be the best and most irrefutable part of her video. We've addressed it line by line, sentence by sentence, the interview with Joshua Swamidass. So let's play the video. That's enough in terms of introductions and backstory and context and all the fun stuff. So let's screen share and give me the A-OK, guys, with audio-wise. And check the chat, make sure everything's good. Dessel says it's Strawman Swamidass. You know, Swamidass blows my mind. I think he's kind of a troll at this point because his responses on his blog are hilarious. Doesn't address anything. I've actually called him out in these videos on just flat out misrepresentations. Like, they can't even be defended other than him just correcting and saying, I'm sorry that I absolutely misrepresented Dr. Jensen. And like, I don't know if he's actually being for real. And then he goes into these debates with like Dr. James Tour on abiogenesis, Michael Behe the other day on intelligent design, and he just gets schooled. He gets demolished. And I'm thinking, like, is he just trying to get attention and doesn't really care that his argument? If I had $1 for every time he recycled an argument that has already been demolished, I'd be a millionaire, guys. So, yeah, I think he's proud of his straw man arguments, though, Dessel. So, good point. Doki Doki Bible Club. Super sticker. Thank you so much. And, okay, chat's all good. Good to see you guys all in the chat tonight. Anybody who has not yet seen Sal's lecture, part 3 on protein probabilities from earlier, wow. All I can say is WOW. Wow. It was good. So please check that out. The Unsolvable Problem for Universal Common Ancestry. And the lecture series can be found on the playlist. Yeah, he started off good against Behe, but then flopped. Yeah. We're looking forward to hopefully having Behe on in January. Dessel's been a blessing helping us out. Ian Chen in the house. Ian, good to see ya. Good to see you. Always a pleasure. Always a pleasure. So, okay, I'm going to screen share. I'm going to play Erica's video in its entirety. Okay, guys, I'm going to mute myself so there's no echo. Then we're going to deal with it. I think it's another few minutes of her video, perhaps. The one tomorrow night on Radioactive Decay, we are going to be going through quite a bit of it and stopping probably every 10 or 15 seconds and just really addressing every point, showing that she even misunderstood even the basics of radioactive decay. So I'm going to be having George with me on that one tomorrow. And then we're going to be saving most of the flood stuff and the so-called heat problem. We're going to be having Bob Enyard on. We're going to be having Dr. John McKay on. Guys, we got content, interviews, debates, discussions for you guys for the next 1,000 years. So anyways, time to screen share. You're not going to be able to hear from me. I'm going to mute it so there's no echo, and we're going to let our video play through. Here we go. Screen share, share the audio, and let's have some fun, guys. When we actually look at animal kind, we can see that there's oftentimes a lot of diversity, let's say within the field. For example, which is what we would expect. So she tried to debunk that by pointing to species, specific species that have experienced bottlenecks, whether it's due to inbreeding. There's a number of reasons that can reduce genetic diversity. Look at the cheetahs. The cat family in general has high levels of genetic diversity, because her question to G-Man was, if species within the same family that we say is the same kind, say the cats, the feline, some of them have more DNA differences and DNA diversity separating them, yet we as creationists conclude they're the same kind. Then humans and chimps, she'll say, have less DNA diversity, DNA differences separating them. So why would we conclude two cat species are of the same kind, yet they're separated by more DNA differences, and not conclude that humans and chimps are? Well, like I said, we'd expect the lower levels of genetic diversity in humans, more in the animal kind. So she completely failed right off the bat on one of the 0.1% things that she tried to actually touch on by pointing to a species. I believe it was a gorilla one. I'm going to leave the video in the description. Actually, you can see it in the slide before this.
You've missed the point entirely.
I don't know where standing draws the line within the ape kinds, as some creationists do have each hominoid as its own biblical kind. But even if Standing for Truth tries to use genetic diversity as his great separator of kinds at the family level, he runs into problems. Because there are entire families of animal with lower genetic diversity than just humans. So still, no standardization, guys.
What are your thoughts, Matt? And then we can move on. All right, guys. So I want to point out the fact that she admitted to her straw man. Okay. Now, this was mainly, though, I really do believe the only reason that she admitted to her mistake on how she originally misrepresented the argument from months ago. Okay. Because she was pointing to, for example, you could point to like a species within a family. Say the felids, you can point to the cheetahs that have extremely low genetic diversity and say, oh, wow, that right there refutes the creationist expectation that overall animals are going to have more diversity. But that's one species within the family. We'd say that family is the same kind. Okay. Kingdom, phylum, class, order, family, genus, species. Species, genus, family. Now, here's the thing. The overall family of the felids would still have more genetic diversity overall than humans. But yeah, a species within the family could experience bottlenecks. Okay, of course. They could experience population crashes. So she acknowledged that she misrepresented us. Now, Emo, out of all people, corrected her. So I give Emo credit for that one. But I think the only reason she admitted to her mistake was because somebody of her own side called her out on it. She will never admit to all the huge number of straw man arguments and mistakes. And honestly, just kind of straight up dishonest talking points against she's not being dishonest because she was repeating them from people like Evilgrad, Dan, okay, Dodgeball Dan, Swamidass. So it's not really her fault, but she's not going to admit to her mistakes, okay, that she made in the last 10 or 11 videos that we've rebutted her in regards to her 3.5 hour video here. So that's precisely why, though, she says she's tapping out. Since she's incapable, not just her, none of them. We saw Dan try and refute that video off the cuff. He said blind rebuttal, and within 2 minutes into it, he realized it was such a specific rebuttal where Ramad and I were addressing very specific claims by Swamidass and Erica that Dan was incapable of being able to correct, because the only correction the evolutionists could have had in regards to that video on the Y chromosome was just to admit that they misrepresented or did not understand. Okay. Doki, thank you so much for the super sticker. You guys are awesome. All you guys are the superstars, life and blood of this channel. All your amazing support is why we're able to give you so much content daily. We've got so many good interviews for you guys. So make sure you're in the chat, the live chat of those interviews. Want some good questions. You guys always give us good feedback. So Gutsick Gibbon herself, she's incapable of addressing these arguments, of course. Okay. And it's not really her fault. Like I said, she's just getting them from others who have straw man. It's like what it is, guys. It's a ripple effect of straw man arguments and straight up misrepresentations. It's a shame, really, is what it is. But I want to point out the fact, okay? I want to point out the fact that her pointing to an exception to the rule when the rule is that we see animals having a greater diversity than humans. Okay, so I'm going to address a lot of that as to why that's the case. Okay, so I always point out the fact that the evolutionary community, they were shocked when they found out just how low, how human genetic diversity, we have extremely low diversity. We're all 99.9% similar. This was not predicted nor expected by the evolutionary community. That's why they invented the post hoc ad hoc out of Africa population bottleneck, okay? Now, what's funny, my 2-hour video on Swamidass, he tried to say that creationists have never answered the question as to why animals do have overall lower genetic diversity. And then she wants to point to 1 or 2 exceptions as if that's rebutting the rule that says animals overall have more diversity than humans, which is just ridiculous. But Swamidass claimed that this wasn't even addressed, apparently. And I showed for 2 hours many quotes, many articles from creation scientists who have exactly addressed that issue and made predictions. And I'm going to show a couple of those later, guys. Now, here's the thing, though. The evolutionists, they need this population bottleneck, okay, in order to explain the low genetic diversity. This is what we expected given the Bible. The Bible says that God created 2 people, Adam and Eve. That right off the bat restricts genetic diversity, okay? So we would have very precise expectations, lower genetic diversity in humans. Now, here's the thing. We also have the flood bottleneck. And then we also have, which Gutsick Gibbon doesn't seem to acknowledge, we have the Babel event, which was essentially for humans an additional bottleneck. Okay, animals, they migrated and filled the earth after the flood, but what did humans do? Well, they didn't listen to God, and they congregated amongst themselves at Babel hundreds of years later after the flood. Okay, what this would have done, guys, is limited. It would have limited genetic diversity even more. This would have been another, essentially, bottleneck. So we would predict, based off the creation event, the flood bottleneck, and the Tower of Babel event, we would predict low genetic diversity in humans. And that's exactly what we find. While the animal types, for the most part, we would expect higher levels of genetic diversity. Now, there's always an exception to the rule, okay? Always. And I acknowledged that in the last video. And Erica here wants to point to some exceptions to the rule as a rebuttal, completely gloss over the fact that this is essentially an unexplainable and fatal problem to their theory. Okay? Now, I want to point out the fact that when exceptions to the rules are your best arguments, you know you've lost. Okay, so let's break this down. So animal types, they'd have more levels of genetic diversity. Look at chimpanzees. You know, whenever I speak on this, I think of chimpanzees. Look how much diversity they have. We can look at felids, for example. And not to mention the fact that we can look at the CO1 gene. We can look at that recent study on barcoding and the low genetic diversity found in the CO1 gene. That's demonstrates that over 90% of all animals, all species, arose at the same time and recently as well. And once again, they've had to invoke what? Selective sweeps, population bottlenecks. So here's the thing, okay? The Bible was written first. Evolutionary theory did not predict any of this data, okay? Did not predict any of this data. And Dessel Drace has a good question, actually. Why are those the exceptions? So I'm going to address that in a second. Actually, Dr. Carter addresses that. And I'm going to pull up a video on that. So here's the thing. Overall, animals are going to have higher levels of genetic diversity, but within the animal types, the animal kinds, there can be situations of population crashes, okay? Population bottlenecks, for example. Domesticated animals will have oftentimes lower levels of genetic variation, genetic diversity, because they're domesticated. You know, they're not spread out widely, for example. They're oftentimes inbred. So we can look to these exceptions. That's why it's difficult to just look within animals and say whether or not elephants are going to have more diversity than another animal type, whether it be a species, genus, family, for example. But overall, because that was Erica's argument, essentially. Actually, give me 1 second. I want to see if... Okay. I want to make sure that I've got the Dr. Carter video up. And actually, what I'm going to do, guys, is I'm going to pull it up right now, as that's one point I do want to address. Now, here's the thing. So as I'm pulling up, I'm just going to look it up here. Dr. Carter addressed it in our interview with him, but he also made a video of it recently that I want to play for you guys, okay? And let's see. Genetics. Okay, so good to see everybody here. I hope everybody's having a good night. So essentially, the original argument from Gutsick Gibbon was, listen, you guys as creationists, you separate humans and chimpanzees and the other great apes, right? We say not related, independent origins, but you guys conclude that all the species of, say, cats within the felid family, they are oftentimes separated by more DNA differences and more genetic variation than humans and chimps. So why conclude that all the species within the felid family are related, house cats to jaguars to tigers to lions, but you won't conclude that humans and chimpanzees and the other great apes are not related? Our conclusion is that they're not related, but yet separated by fewer differences. That was essentially her original argument. So we pointed out the fact that it appears, based on all known data, scientifically and theologically, that God would have front-loaded animal kinds with a greater ability to diversify. And this probably has a lot to do with the fact that God created animals in bulk. He created fully functioning ecosystems, populations of animals, but yet he created humans as two, Adam and Eve. A lot of evolutionists and critics and even creationists forget that the two of every kind and seven of some was the flood. That was what Noah was commanded to bring aboard the ark. But the actual creation event, it wasn't just two birds, two fish, two cats, two dogs. No, fully functioning ecosystems with a lot of diversity built in. So that is why when we look to levels of diversity, we would expect more in animals, less in humans. Now, of course, let's look at animals and humans. Genetic diversity would have been lost at the time of the flood. Okay? Now, when we actually look at the genetic variants, what's fascinating in humans, we can find about 10 million common variants. So even if Adam was front-loaded with, say, 20 million, and he loses half, we're still left with 10, which can explain everything we see today. There's roughly 10 million common variants in the world. Dr. Carter talked about this, actually, in our interview with him. Okay? Now, it would also be expected that the animal kinds brought to the ark would have been the most heterozygous at the time. Now, yes, diversity and heterozygosity would have been lost at the flood, but because the flood was only one generation followed by rapid and exponential population growth, very little of that original created heterozygosity was lost. But with humans, even if Adam lost, say, 10 million and was left with 10 million, still explains everything we see. Still explains everything we see. So let me pull up this video for you guys on diversity within animals and what kind of predictions we can make there, and why it's not so easy due to population crashes, due to domestication, due to a number of reasons, okay? So here we go. Genetic diversity on the ark. I just need to screen share with the audio. Give me 1 second. Doki Doki Bible Club, thank you so much for the super chat. Now, I want you guys to be able to hear this fully without an echo. So what I'm going to do again, ladies and gentlemen, is mute myself and play the video. Here we go, guys. Then we're going to go through a couple articles too, and then finish off our portion on genetic entropy.
As a student of history, I love coming to out-of-the-way places. I'm here in Dallas, Georgia. I'm at a newly developing park. It's a park honoring the Orphan Brigade that until the recent past, there was nothing here. It was just woods. It's as if the world had swallowed up the history of a group of people that lived and died right here for a short time. And the Orphan Brigade were Kentuckians. I'm way down south here in Georgia. Kentucky was a northern state, and they're called the Orphans because they had joined the Southern cause. They had several famous leaders. One of them was a former vice president of the United States, John C. Breckinridge. Another was Abraham Lincoln's brother-in-law, Brigadier General Benjamin H. Helm. He's also the son of the Kentucky governor. I mean, this is a very important brigade, and right at this place, they ran into the Union lines unexpectedly, and about 600 of them died that day. One of the reports said they ran into a sheet of flame and death was feasting in our midst. But a lot of this history has been lost, even though this was 1864. That's not that long ago. It's not even 2 centuries ago. Most of the physical evidence has been destroyed by construction, by people moving in who have no idea what happened here in the past, by erosion, and by bad record keeping. It's as if you could put together a patchwork of events, but most of the details are already gone. And this was just 1864, and that's less than 200 years ago. So we do have a nice record of what happened here, but it's incomplete. And the further back in time you go, the less complete the records become. Now let's jump back in time to about 1000 BC, the border of modern-day Germany and Poland, way up north against the North Sea. A battle was fought there, a battle completely unknown to the history books. Until an amateur historian had discovered a leg bone poking out of a riverbank, they didn't even know this battle happened. And as they started excavating, they realized that all of their understanding of early European history was wrong, because there weren't supposed to be large battles. There weren't supposed to be large groups of people. There wasn't supposed to be organized Bronze Age society so far north at that time, and yet here are the bodies. In fact, in 450 square meters, they excavated no less than 130 different people. And 2 of them were women who were fighting in this battle. Who are these people? Where do they come from? We have no idea. But we've been able to use genetics to pull apart some of the puzzle. It turns out that the people on both sides of this battle were closely related. It wasn't like it was an invading army from far away. It was a massive battle between 2 competing groups that were culturally, or at least genetically, related to one another, fighting over this marshy, swampy area that used to have a wooden bridge crossing it. And we have no idea why. Now, the reason I bring all this up, talking about history, and there's a hint of genetics in there, is because we have to answer questions about history, genetics, and the Bible. And I want to illustrate that a lot of the information we simply cannot know. We can infer a little bit, but there's a lot we can't actually know for certain. For example, I had an article appear on creation.com just last week. It's called Genetic Diversity on the Ark. As a speaker, I travel around to a lot of different churches and schools and in group settings, and I answer a lot of questions. And online, I answer a lot of questions on email every week, and a lot of questions I get asked many times. And so for this particular question, I said, that's it. I'm just going to type it down, so now I have an article about it. And the question is, what about the genetic difference between clean and unclean?
Okay, so for more context, now that we've dealt with humans and why they have such low genetic diversity and why this is exactly what we would expect, given the fact that God created 2 people, Adam and Eve. Not predicted, though. And I've asked for months now, years probably, show me where evolution has predicted the levels of genetic diversity found in humans. Where they predicted the Y chromosome data, the mitochondrial DNA data. They won't show you where they predicted it because it was not predicted. But it's exactly what the Bible would have predicted, would have expected. It had to be true for the account of human origins and the special creation of Adam and Eve to be true. And it just so turned out to be true. But they always forget the Tower of Babel event. Because Joshua Swamidass said, why do animals have more levels of genetic diversity? And fails to remember that directly in Genesis, the question is answered that at the Tower of Babel, animals migrate prior, spread out, populate, They're being fruitful and multiplying, and humans are at Babel forever a number of years, further reducing genetic diversity. And that's why today we see less genetic diversity in humans. But what's funny is Swamidass was saying, I've never seen creationists deal with this. And I'm going to show you a couple articles and a section in the book that I have, Evolution's Achilles' Heels, where that is exactly addressed. But it's also common sense, just reading the Bible. It's exactly what you expect. When I first read Genesis, it was obvious to me that God was creating fully functioning ecosystems, creating animals in bulk and in populations. And it was only Adam and Eve that were created as a pair. It was the flood event where those populations were reduced to, say, 2 or 7 with the animals. But here's the thing. That means the animals, although you'd get 2 of some, they were chosen by populations of animals that had greater levels of genetic heterozygosity. So that means more heterozygous animals would have also been brought on board the ark, while humans were still already having lower levels of genetic diversity. So it's all easily explained, and quite easily too, actually. But that's why we look at molecular clocks, speciation rates, DNA function, to address the question of ancestry. The absolute number of DNA differences, levels of diversity, not quite as significant as those other factors that we're making direct predictions. So I'm screen sharing still, so I wanted to show you guys before we get back to the video. This is the article that Dr. Carter is pointing to. Ark genetic diversity. So we're going to go through that a bit. Here we go. Genetic diversity on Noah's Ark. We're going to go through that a bit after this video. So Nicholas made a good point that the 1.75 speed might be too fast for some. And so I dropped it to 1.5, guys. It just means we'll be spending a little bit more time watching the video, but it is important because now we're actually delving right into the animal kinds themselves and seeing what would we expect. Lower levels of genetic diversity in, say, elephants as compared to mice, or how much levels of genetic diversity are we expecting in fish versus birds? Okay, so now we're kind of focusing in as compared to looking at just humans, which we would say are created independently and specially as compared to the rest of the biological world. So once again, guys, I'm going to mute. Ian, good to see you. Glad you joined us. Good to see 20 people in the chat, even at 3 a.m. God bless everybody. Thank you, Doki Doki, for the super sticker. I appreciate the super sticker master, I tell you. So here we go. I'm going to mute again, guys, and we're going to play the rest of the video.
Animals. Let me read to you Genesis chapter 7. Then the Lord said to Noah, go into the ark, you and all your household, for I have seen that you are righteous before me in this generation. Take with you 7 pairs of all clean animals, the male and his mate, and a pair of the animals that are not clean, the male and his mate, and 7 pairs of the birds of the heavens, also male and female, to keep their offspring alive on the face of all the earth. Okay, so we have a difference between clean and unclean. Now, granted, the law has not yet been given. The law is not going to be given for another 1,000 years in the time of Moses. But at this point in time, they already had some idea of substitutionary atonement. Just go back to the Cain and Abel story, where Cain brought vegetable material and Abel sacrificed a sheep. So, or at least sacrifice an animal. We know they had an idea of substitutionary blood atonement. They had some, at least, idea of clean versus unclean. And here we have Noah bringing pairs of animals. Now, some translations say 7, some say 7 pairs. I'll let the theologians argue about that. All we know is that there's less unclean animals than are clean animals per kind. So maybe there's, 2 elephants versus 14 sheep, 2 mice versus 14 cows. So doesn't that automatically mean that there should be more genetic diversity amongst cows and sheep today than amongst mice and elephants? If you have more individuals, can't you have more genetic diversity? The answer is, we don't know, because clean animals tend to be found in flocks. They tend to be inbred. We have no idea the genetic history of the flocks that were used to populate the animals on board Noah's Ark. We simply cannot know that. So we cannot say, oh, there should be more diversity in clean animals. Who says? Plus, different groups of animals have different DNA repair.
Good question I just seen come in from Actually, I see Kylo Kenny. Good to see you. God bless you, brother. You're a blessing. I appreciate all you do for us. One Punch Man, good to see you. Good to see you, brother. Catherine Stormguard. So before I forget, because sometimes the chat goes by, I forget about questions, asks, did genetic entropy happen before or after the extreme diversification after the flood? So good question. At the top of my head, I can give a few brief answers. At the time of creation, Adam and Eve would have had the most created heterozygosity. They would have had the perfect genomes with the most ability to vary. That's why I oftentimes point to the PRDM9 enzymes that assist and help in recombination. And recombination gene conversion can work most effectively in organisms, let's say Adam and Eve at the time of creation, where they had the most levels of heterozygosity. They would have had no mutations. Now, here's the thing, evolutionists, I want you guys to realize that according to our model, because oftentimes critics, they will argue against what's called evolutionary creation, because they're assuming that we explain the origin of all genetic diversity as mutations over time. No, mutations were introduced after the fall, okay? Genetic entropy would have been introduced after the fall. Mutations are corruption in genetic information. And I'm going to get into that later when we get into our part 2 of genetic entropy. So nowadays, we see roughly 100 new mutations per person per generation. And they're passed on. The more functional the genome is, the more deleterious and damaging they are going to be. I always point out selection can remove the worst, most detrimental mutations, and it can amplify the best. But it's those nearly neutral ones, the ones that are just so subtle to fitness that selection can't really see. That means selection can't filter out all of these new mutations that are pouring into our genetics generation after generation. So genetic entropy would not have been as substantial, I'll say, immediately post-creation. Environment was much better. The genomes were much better. Probably more fully functioning DNA repair enzymes. Now, here's the thing, though. In the pre-flood world, men, women, humans, they were living a lot longer. So there's something called patriarchal drive. The longer you're living, okay, now here's the thing. Your somatic cell lines, your skin cells, for example, those mutations that accumulate in one's lifetime, because you accumulate a lot of mutations in your lifetime, okay? That's primarily why we die, is mutation accumulation. But it's only the ones in the reproductive cell lines, the germ cell lines. Those are the ones that get passed on to the next generation. They make it through. And thank God for DNA repair enzymes, because if we did not have these enzymes that I look to as forward-thinking mechanisms, we'd be extinct in a few generations. Because our bodies and our cells and our repair systems are constantly correcting these mutations and errors in the cell replication, essentially. So there would have been less mutations in the pre-flood world. But at the same time, people were living longer, 300, 400, 500 years old. That means they're accumulating more mutations, and therefore more mutations in the reproductive cell lines that are passed on. But still probably not as much today, even in their long ages, because it was a cleaner world. It was the flood that rearranged the entire earth, okay? And the negative effects. We know that environment, because oftentimes it is environment plus genetics equals phenotype, okay? That means that environmental factors can trigger mutations and corruption in genetics. That's why epigenetics is so fascinating right now. So in the immediate post-flood world, that is where I would say we would have seen the rapid increase in mutation accumulation due to environment, reductions in ages. But even for a few generations after the flood, we'd have what's called patriarchal drive, where now in the immediate post-flood world, we're accumulating even more mutations than we were in the pre-flood world. That means more are being passed on, which is a scary thing. That's why we look to populations like the Neanderthals. If they were founded by a biblical patriarch who lived to a really old age, that population, okay, they would have started off with a whole bunch of mutations. They would have already started off with different sets of biodiversity. So mutations have always been accumulating. To make a long answer short, mutations have always been accumulating since creation. But I would say more mutations have been accumulating after the flood because of the environment, the rapid changes in longevity. But we've always been accumulating mutations, maybe not quite as much as we do now. But that's why I say there's shelf lives on genomes, because take this point of most mutational damage. Okay, take this point of genetic entropy and take this back to a point of least increasing genetic entropy or least mutation accumulation. That'd be a point of Adam and Eve, perfection, no mutations. Now, they'd still have DNA differences, but we would say that those DNA differences were the result of creation. God front-loaded Adam and Eve with all of these DNA variants, DNA differences, and for theology purposes, God said, be fruitful and multiply. It wouldn't make any sense for him to carry that out through cloning. So, yeah, the second you mentioned genetic entropy, I think I can't make a short answer out of that question. So rapid diversification after the flood would also involve inbreeding, decreases in genetic diversity. That's what inbreeding does. So all the effects of the post-flood environment, post-flood genetics, decrease in life expectancy, all of these things, I would say, would have increased mutation accumulation. So, okay, so let's keep going. Catherine says, thank you for the response. No problem. Do you think GE was the reason the rapid diversification eventually slowed? Typically, speciation events occur due to isolation and shifts from heterozygosity to homozygosity. So more allelic diversity to less. And once that species, let's say a population that branched away, okay, so now we got a subpopulation. Once their genetics change enough, they can be considered a new species. Like we just seen a couple of years ago on the Galapagos Island, new species of finches. And the new species, it was a hybrid species. They came about through exactly that, right? So shifts in more genetic diversity to lower levels of genetic diversity, inbreeding, these things. So yeah, speciation events aren't due to increases in genetic diversity, new novel information. It's typically due to the loss of genetic diversity. So do you think GE was genetic entropy, mutation accumulation, since we explain all DNA differences for the most part as created heterozygosity, we don't explain new species as a result of the accumulation of mutations. Those DNA differences are there. Now we just have to shuffle them up, right? Recombination, gene conversion. We need breakaway populations, isolation, shifts in heterozygosity or homozygosity. This can produce new species quickly. But here's the thing. That's because all of that DNA variety is already built in to animals. It's built into Adam and Eve. Evolutionists, they explain the origin of all DNA differences as a result of mutations over time. So they got to build up the mutations. They got to build up the genetic diversity. And then, yes, they can look to recombination, gene conversion, of course. But the gene conversion, the recombination is acting on those pre-existing DNA differences that they say have originated through mutations. So that's why they require lots of time. Time is not an issue for us because we just say those DNA differences, that genetic diversity is built in at creation, which makes testable predictions. People will say, oh, that's post hoc ad hoc. Well, no, because now we can make predictions on DNA function and very specific predictions on DNA function, predictions on DNA positions, and also predictions on DNA positions in the genome that, hey, if this experiences a mutation, it's going to lead to a disease. And we can even name specific diseases because if it's a functional DNA unit and it experiences a deleterious mutation, it's oftentimes disease causing. So we can make predictions. If this is true, that God front-loaded animals and Adam and Eve with pre-existing functional DNA differences, we would predict DNA function. We can also make predictions on mutation rates, speciation rates. So Kylo Ken, in the YEC model, what are the genetic boundaries to speciation? So what I like about Kenny is he doesn't believe in large-scale evolution. Our models are slightly different. So I think people would profit from not a debate or anything like that, maybe just us kind of throwing questions off each other. But genetic boundaries, we would say that animals will hit walls. Okay, so if Adam and Eve and the created types, created kinds, at the moment of creation, they would have had the greatest levels of heterozygosity. But over time, as more diversification events take place, more speciation events, that means more loss of heterozygosity. So eventually you now have more homozygosity than you do heterozygosity. So think at creation, you got more heterozygosity than homozygosity, while today we would expect more homozygosity than heterozygosity. So for example, the horses, the equids, they got more homozygous gene sites today. That means they would have had more heterozygous gene sites at the flood and the most heterozygous gene sites at creation. Look at the Chihuahuas. I mean, they have lost a lot of allelic diversity. They have hit a wall. You know, there's not much more they can do in terms of variation versus take two wolves. You take two wolves, with enough time, you could probably get all your domestic dogs again. But you can't take two Chihuahuas and breed something like a wolf, given however many generations, because the information's lost. So creation, you got the most information. Today, there'd be less than at creation. Another 100 years, 200 years, 1,000 years, even less. So the more heterozygosity that's lost over time, these animals hit walls. And when they hit walls, we're now looking at barriers to change. Less change possible. And we see, that's a really good question, though. Dr. Jensen has entire, papers on that one. So that's a really good question. All righty, here we go. Dessel says, Kylo Ren is the worst villain in the history of villains. Yeah. If we're talking Star Wars. Okay, let's go to Catherine Stormgard says, much appreciated. No problem, no problem. On the spot, those are the answers that come to me. But we've got entire videos and presentations and stuff on this. So here we go. Let's go back to the video. And I'm going to mute myself, guys. You just heard me rant a lot there on a few really, really good questions. So thank you, Kenny. Thank you. See, I want to put, because a lot of people, I want to just address this. A lot of theistic evolutionists, even old Earth creationists, they'll say that creationists, young Earth creationists, believe in hyperspeciation. But no, because that misunderstands the explanation that both evolutionists and young Earth creationists have for the origin of genetic diversity. So we're proposing the origin of genetic diversity is the result of initial creation, okay? That's why we call it created heterozygosity. But evolutionists, they explain all DNA differences as the result of mutations over time. So they need to build up those mutations because natural selection, which we both believe in, acts on what? Random variation. For us, the random variation is already built in, which makes sense. God said to be fruitful and multiply. No sense for God to create Adam and Eve and the animals genetically homogeneous. That wouldn't make any sense. Him creating animals and Adam and Eve genetically heterozygous, that makes sense. So if those DNA differences are already built in, well, now it's easy. All we need is recombination, gene conversion, and we can see variation and change and rapid diversification in just a couple generations. Think about this. Myself, my wife and myself, okay, my wife and I, we could hypothetically have 1 million kids if it were possible and we could live that long. And because my wife and I have built-in heterozygosity, everybody in the chat, you all have built-in heterozygosity. You know, people always scoff, oh, created heterozygosity. We have heterozygosity today. That is why we could hypothetically have 1 million kids. And guess what? Every single child would be genetically different, genetically distinct. They'd look different just through recombination, shuffling up those DNA variants. I've got about 3 million common variants. And there's only about 10 million common variants around the entire planet. A lot of rare ones, but common ones. So throw, I would say, 20 into Adam, lose half at the flood, and now we're left with 10 around the planet. So it fits nicely. So it's not hyperspeciation since it's already built in. The more we lose, the less potential now for diversification. The potential today for diversification is less than the potential at the flood, less than the potential at creation, right? So this comes to mind. I debated a zoologist, herpetologist, Adam Heat. We discussed this greatly. He's a zoologist, right? So he's into this kind of thing. And I said, as creationists, when we look back in time, what we're looking back to in time to the creation event is the expansion of genetic information. By expansion, I mean we're looking back to a point in time of the most possible genetic variation. But evolutionists, guys, when they look back to the creation event, you know what they're looking back on? The contraction of information. Okay, because they want to start out as a single-celled organism, and that single-celled organism evolves into a multi-celled organism, and that multi-celled organism evolves into a fish, and then an amphibian, and a reptile, a mammal, a bird, a monkey, a man, right? This all requires the expansion of genetic information. They need to explain the arrival of the fittest, not just the survival of the fittest. They need to explain the origin of body plans, novel information, meaningful information, not just because a mutation by definition adds something. It adds variation because a mutation is something that was not previously there. But that type of variation that mutations add and mutations lead to, it's like the variation you get on your car with the dents and the scratches and the rust marks. Sure, that's new to the car, but it's damaging. It's not good. Nobody wants dents. I remember when I got my new car back in 2015, I was so pumped. And within like the first week, I must have parked it too close to a car or something at the grocery store because there was a shopping cart dent on it. I thought, look at this. I didn't look at that as meaningful and beneficial and helpful. It's useless. That's worthless variation. So that's the type of variation that is added with mutations. Alterations in the genetic sequences, alterations in nucleotides, okay? It's like a typographical error in a text. It's much easier to break something due to mutations than make something better. So that's the type of variation you're going to get. And I was trying to explain that to Dan in one of our first conversations where, yeah, you're going to get new variation through mutations, but is that variation helpful? Is it useful? Is it beneficial? Because I'll tell you one thing, that dent, that scratch, that rust spot on my car, sure, it's adding something to the car, but nobody in their right mind, unless you're an evolutionist, would say that that's good, useful variation. No, the car was the best when it came off the line. Just like Adam and Eve were the best at creation. They were front-loaded with all of this genetic diversity. That's when they were the best. We're nowhere near Adam and Eve. Ken Hovind makes a good analogy. He says, take a piece of paper that you just got off the printer. Now photocopy that. Then photocopy the copy, photocopy the copy of the copy, photocopy the copy of the copy of the copy. Do that 1,000 times. Eventually you're going to see a piece of paper that's a poor reflection of the original printed copy. It's going to be faded, hardly readable. We're lucky to get up in the morning and be able to breathe and cook ourselves breakfast, given how many generations removed we are from Adam and Eve. We are a copy off 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 a copy. So, uh-oh. You guys are taking advantage of me. All these questions is going to keep me away from the topic of the video. Well, this is kind of the topic. Plus, you guys have great questions. Do young Earth creationists believe there can be some beneficial mutation? No, so definitely some beneficial mutations, especially since we believe that God front-loaded Adam and Eve, not only with DNA differences, but also DNA elements that can help with variation. We call them variation-inducing genetic elements, okay? VIGE, variation-inducing genetic elements. That would be your retrotransposons, like your endogenous retroviruses, your ALUs, okay? We believe that those can assist in variation, and that variation can certainly be beneficial and useful. Now, beneficial mutations is kind of environmentally dependent, because a mutation that's beneficial, and a beneficial mutation is essentially about 1 in a million mutations. But those turn out, when you actually examine them on a molecular level, okay, you go under the hood, and you don't just look at the phenotype, the outward appearance, the outward benefit. Oftentimes it is due to a broken gene, broken protein, broken cell. So even though it is beneficial, like for example, the wingless beetles on a windy island, these beetles, they lost their wings because they kept getting blown away and they died and they can't reproduce, right? It's all about who reproduces the more with evolution. So they had a mutation where they lost their wings. Well, that's awesome. Now they won't be blown away. But here's the thing: it was a loss of information, loss of wings. It's not taking things forward. Or blind cavefish. So in the dark, these fish would get injured, their eyes. They'd bump into things. They'd be damaged, get infected, they'd die early. Well, now these fish have had mutations where they've lost their eyesight. So now they can survive better in these caves that are dark. They can't see. They don't even need their eyes. So essentially it's beneficial in the cave, in that environment, but it's due to a loss. It's reductive, essentially. So yeah, that would be beneficial. We'd admit that it's beneficial. Sickle cell anemia is beneficial. But when you go down on a molecular level, we always say, look at the genotype. What does the genotype tell us with these beneficial mutations? And oftentimes the genotype, looking down at the genetic level, tells us that these mutations are reductive, not beneficial. So good question. Good question. Okay, that was a good 20-minute intermission with some good questions, guys. Let's go back to the video. I'm going to mute myself. And no problem, Catherine. We appreciate you. We appreciate people of differing opinions, differing views. I like healthy discussion, even with those who we might not agree on things, but just to understand our position. So great questions. And here we go. I'm going to mute myself, guys. You won't hear me, just so we can avoid the echo. And we're going to get this video going.
Repair enzymes. They have different strategies for reproduction. Some of them produce a lot and a lot die every year. Some of them produce a few and a lot survive out of those few. Some groups have had historically large population sizes. Some have had historically very small population sizes. Some populations have grown and then crashed and grown again. So putting all that together means you can't just do a across-the-board statement, clean animals should have more genetic diversity. You do not know that, which means we have a lot of options. The Bible has not pigeonholed itself saying this is something we would predict from the book of Genesis. It's not true. We don't know what's predicted because we don't have enough information to make a direct prediction. So however it works out, I'm perfectly comfortable with. We also have to define a particular word. The word is allele. This word is used ambiguously by scientists all the time. I can use it to mean several different things. And so what I mean by it depends on the context in which I'm saying it. An allele is just a variant. It just means that there's a genetic difference between this piece of DNA and that piece of DNA. So classic alleles would be the blue and the brown-eyed alleles in humans, or the A, B, O blood group. Now, A, B, and O, that's 3 different alleles. Does that mean that there's a problem here? Why do humans have 3 alleles if we just started from Adam? If we have Adam only, he has 2 copies of each chromosome, and the blood type gene, he's got 2 copies. He can only be A or B, A or O or O, B or B. He can't be A, B, and O at the same time. Except clearly, type O is a mutation. If you are type O, you have the A gene. A and B have multiple differences, 2 very genes. If you're O, you have the A gene, and there's a mutation in it that prevents the production of a working enzyme. The enzyme that sticks to sugars on the outside of your cells is broken. So therefore, it looks like in the beginning, there were only 2 alleles for the blood type gene, A and B. But even if there are 3 or 4 or 40 today, that's not necessarily a problem because most alleles are very rare. If you look at blood genes, there's a lot of variation. You look at genes that affect height, weight, skin color, hair color, metabolism, there's tons and tons and tons of variations within these genes. There are a lot more than 2 alleles for most genes because we've had thousands of years for mutations to accumulate, and each person has a different history. Each section of your DNA comes from a different family tree, and therefore there are millions of possible family trees. There are millions of possible variants in any large section of DNA. Oh, but wait a minute, what's an allele? Is it a single letter difference? Or is it a big difference? That's part of the ambiguity. You see, the word was used before we discovered what DNA did. There's a gene that makes this fruit fly have white eyes. Oh, the white-eyed allele. Well, was that just one letter or a lot of letters? Was it a giant deletion? We had no idea until way later when we finally started sequencing fruit fly genomes to discover what that trait was caused by. So an allele can mean one letter. It can mean a section of DNA. It can mean a trait. So when someone says, hey, there are too many alleles for such and such, I say, whoa, what do you mean by the word allele? Oh, okay, so in this gene, which is maybe 10,000 letters long or so, there are a whole bunch of different variants. Fine, but look at any single letter in that gene. There's an A or a G, a C or a T, an A or a T, a C or a G. In other words, for almost all variants in the human genome, there are only 2 originals. We share amongst us about 10 million common variants that are found in 2s. Those 10 million are found in every race on the earth. Oh, and you as an individual, I've said this before on biblical genetics, you as an individual have about 3 million places where the chromosomes you got from your mother differ from the chromosomes you got from your father. About 3 million places where they disagree at single letter positions. And if you have 3 million on your own, it would be trivial for God to engineer into Adam about 10 million, maybe more, because we have to allow the possibility that some genetic diversity has been lost, specifically at Noah's flood. So maybe Adam had 20 million, 15 million, it doesn't matter. It's easy to put that into Adam. And then since then, we've had a lot more mutations. So yeah, your genes have a lot more variation than 2. And through recombination, genes have been recombining means if let's
Right? So the point is variation, it doesn't just come about from mutation, right? Variation can come about through other means than just mutation. And even the evolutionists will agree with this. Like recombination, as we were talking about, recombination occurring in sexual reproduction from the alleles, let's say from the original created genotypes, that would over time increase phenotypic variability. Okay. And at creation, we would have had the most potential for phenotypic variability. Now, that's the difference, though, is the evolutionists, they need to explain the origin of the variation. But isn't it funny how we know that mutations are damaging, right? Mutations are the destroyer. Mutations are destruction, not construction. But yet they want to tell us that pond scum evolved into people through a long, long process of mutation accumulation. These mutations are damaging. They're like spelling mistakes in a book, most of them being unselectable. And those are what they say natural selection can act upon and recombination can work with. Now, mutations after the flood, after Babel, as Carter is saying, can result in additional variation, okay? But with that original created variation, that's where we find the most benefit to be had through recombination, gene conversion. It's already there. We don't got to explain the origin of it. So essentially, it's not hyperspeciation unless we were actually also explaining the origin of all genetic diversity as mutations. But here's the thing. If we had to explain the origin of all the species today from 6,000 to 8,000 kinds, let's say on the ark, 4,500 years, and we had to explain all of those DNA differences as a result of mutation, well, that'd be impossible because every single form of life would have mutated themselves to extinction. I mean, that fast of mutation rate that would be required and necessary if we as young earth creationists were explaining all the DNA differences as mutation. Yeah, that'd be impossible. But it doesn't make any sense scientifically, doesn't make any sense theologically. So that's my thoughts on that. Let's keep going.
say there's a theoretical gene where every variant on this particular chromosome was AAAAA, and on its corresponding one it was GGGGG in Adam. Well, recombination can happen, and now we have 4. We have AAGGG, AAAAA, GG, AAA, and GGGGG. That's 4 different variants already, and we only had 1 recombination event. Given thousands of years of recombination, this is exactly what we would expect to happen. We have a lot of allelic diversity, and the whole challenge of, oh, there's too many alleles for these genes is actually not true. It's actually a mirage. In that same article, I answered questions about which of the different races came from Shem, Ham, or Japheth. And I very strongly pointed out that all of them, all races come from all 3 brothers and their 3 wives. Why? Because in the generations leading up to the Tower of Babel event, races can't develop until after Babel. Because if you've got Shem, Ham, and Japheth, the Bible says there's one language. They're intentionally staying together. They're not spreading out. That's a recipe for social cohesion. In fact, God didn't like their cohesion. He said, these people are evil. I'm going to spread them out. So we confuse their languages. But if you have social cohesion, you would have all 3 of the brothers' sons would be marrying all 3 of the other brothers' daughters, and vice versa, and vice versa. You can't get a Shem lineage, a Ham lineage, and a Japheth lineage. It's not possible. The 3 brothers' lineages are mixing together. At Babel, we spread out, but those 5 generations, plus or minus, between Noah and Babel, is Noah and Peleg, which means we're all equally descended from the 3 brothers and their wives. There's no way around that. This also means that you cannot say, oh, well, maybe Ham was black, or maybe Ham's wife was Asian looking. That's nonsense, because all of those genes are shared within this one nuclear family for multiple generations. They're completely scrambled up. And then when God divides the nations, yes, he divides them according to Y chromosome. He divides them according to male ancestry, but only the Y chromosome. The Y chromosome doesn't affect the way people look. It controls male versus female, but not black versus white or Asian or anything like that. It's not a factor here. So if you're still holding on to the idea that there are 3 main races in the world, the Caucasian, the Negroid, and the Mongoloid, get it out of your head. It's not true. It's not true genetically. It's not true scripturally. It's not even true according to the evolutionary theory. That version of history was invented by outright racist 19th century evolutionary scientists. It needs to be dispelled with. It's simply not true. And one way to know that is, sure, if you go to Iceland, Japan, and Southern Africa, you can find people that look very different from one another. But what happens when you go in the middle? What happens when you go to Egypt? The genetics of Egypt are very much like the genetics of the Mediterranean basin, not like Southern Africa. What happens when you go to a place like Tajikistan, Iran? What you find is people that are a blend. Yeah, there are extremes, but in between there's a gradation. There's no line you can draw on a map. Say, here's the difference between the Japhethites and the Semites. It's not true. Plus, biblically, if you look at the table of nations, they all lived on top of each other. So I'm not sure why people want to hold on to this 3 races idea. I'm encouraging you to please get rid of it. Go read my article on creation.com. Now, even though I've come out to this lovely natural area, nature is going to get the best of me, and I'm sure you can hear the thunder, and here comes the rain, so I got to pack up and get out of here. You all have an awesome day, and I'm going to go have fun stomping through.
Amen. For those people, and I don't think there's many of you out there who still believe that there's actually races, like Dr. Carter says, get it out of your head. There's one race, the human race. We are all made of one blood. That's what the Bible says. And every single, so-called race can easily be explained from Adam and Eve. Just through that front-loaded genetic diversity can explain every single shade of skin on this planet. There is no such thing as races. We're all 99.9% similar. The evolution has never predicted it. The Bible, guys, remember, the Bible was written first. Okay, evolutionary theory did not predict any of this genetic data. They did not predict a bottleneck. They didn't predict going through the Middle East, as the genetic data tells us. They didn't predict a mitochondrial Eve, a Y chromosome Adam. Okay, the evolutionary model, what's funny, is it is becoming more and more biblical over time, the more that they actually face the data. So here's, guys, so since I'm still screen sharing, remember Dr. Swamidass? He said, creationists, they've never addressed this. They don't explain the levels of diversity, this, that. This is from Evolution's Achilles Heel. Let's read it here, okay, guys? Let me know, give me the A-OK in the chat about the sound and all that. So let's see what it says. This is Dr. Carter. Interestingly, and as an aside, animals are different. Yeah, that's right. That's what we're talking about today, guys. Humans are exceptionally uniform when compared to most all animal species, right? Just as I was saying. Look at this. I'm not just making this stuff up, guys. Chimpanzees are 5 to 6 times more diverse. Guys, chimpanzees are more diverse within each other than humans and Neanderthals are. But the evolutionists had an entire debate about it on Modern Day Debate. They want to say, no, Neanderthals are a separate species, a sister species. It's like Neanderthals and modern humans, 99.7% similar. There's less diversity within Neanderthals and Homo sapiens than just between different variants of chimpanzees. Oh, I don't get it. The common house mouse carries huge variations in their population. Dessel Dre says audio good. Thanks, my man. Including multiple chromosomal rearrangements. Good thing I got my glasses on, guys. This is small writing. My fault, though. Examples of this in nature abound in the animal world. Most of this is due to degradation of animal genomes over time. Some of this is also due to the different starting point, right? So according to our model, we've got different starting points. Now, when you're arguing against people's models, you don't want to argue against a straw man, right? When evolutionist critics argue against our model, they're oftentimes arguing against evolutionary creation, where they think that we explain all DNA differences as mutations. That's not true. So some of this is also due to the different starting point of animals compared to people. The Bible does not, so this is what I said earlier, so it's being corroborated here. The Bible does not say that God created two of every kind of animal. Iger Television, good to see you. Hope you're well tonight, brother. In fact, one might assume he created a functioning worldwide ecology that included high diversity, as also evidence from the fossil record. Just look at the fossil record, guys. The amount of variation and biodiversity in the fossil record when it comes to animals is amazing. It's fascinating. I've always found that fascinating, the fossil record, even before I was a saved Christian, even before I was a young earth creationist. So let's see. Evidence from the fossil record within each kind. It is true that only two, Doki Doki, good to have you back. It is true that only two of most kinds of animal were on Noah's Ark. But, and this is what I said earlier, but they were selected from a potentially much larger genetic pool than were people. You know, they'll say, oh, Standing's making this stuff up. Guys, I'm not the very first young earth creationist, okay? I've actually read the literature. Like the fact that, I mean, go watch that 2-hour video on Swamidass. He literally, he said in his blog, he actually said, I can't believe Dr. Carter or any young earth creationist has never addressed this question of diversity. It's like, what? I mean, it's been addressed over and over again. Take the blindfold off. So let's see. Since most of the genomic data available today is human for obvious reasons, we are far from being able to build a model of genetic history for most animal species, but these are interesting points to consider. Besides the number of common variations found in the human genome, there are untold numbers of rare variations as well. These tend to occur only in isolated populations and are an indication of mutations that have occurred since Adam. Indeed, since Babel, these include blue eyes in the European population, sickle cell anemia in the African population, and many super rare variations that only occur in a single tribe, family, or individual. We share a huge amount of genetic variation. So I want to go back to Dessel's question earlier, which was really good. Here's the thing. There's not a one-size-fits rule. You're always, in everything, guys, in everything, you're going to find an exception to the rule. Back in the day, before it was just universally accepted that smoking kills, smoking caused lung disease, caused heart disease, you know, people would say, well, you know, I know this family member who smoked all their life since they were 12. They lived till they're 95. They're fine. Guys, are you really going to use an argument against smoking being bad and dangerous by pointing to your one family member who happened to just smoke their entire... Imagine if they didn't smoke. They probably would have been even more healthier and lived even a longer age than 90 or whatever it was. So there's an exception to the rule in everything. And guys, please, please watch Erica's video here. Look at their arguments. Their arguments are essentially Exceptions to the rules on everything. Oh, McDonald's, breakfast, lunch, and dinner, the healthiest thing. Go there for breakfast, get an Egg McMuffin combo. Go there for lunch, get a McChicken sandwich combo. Go there for dinner, get a couple of quarter pounder combos. You know, it's healthy for you. My Uncle Bob, he did that his entire life. Look at him, he's fine. I mean, you know, you hear that all the time. That's what they're doing here. That's what Erica's doing here. You know, it's not very good for standing. There's a couple animal families here where they do have lower levels of genetic diversity. Yeah, it's not a one-size-fits rule. There are population crashes, okay, population bottlenecks, populations that are just smaller for a number of reasons. Domestication, you have to consider that as well. These things can lower diversity, okay? But it's overall. So here's the thing. She's 0 for 2. So her first attempt was to look at a species that has low genetic diversity due to a bottleneck, okay, that reduces diversity, when in fact we're talking about the family, okay? Kingdom, phylum, class, order, family, genus, species. Oftentimes we'll say that the family level is the kind level. Therefore, the felid family should have more diversity. You can't look at the cheetah and say, oh, looks like you're wrong, biblical creationists. No, that's not how it worked. Then she tried again, but all she did was picked out a couple exceptions. And here's the thing, though. This is BioLogos loves this argument. Dr. Vanima used it on Jensen. He said the same thing. Why do you conclude humans and the great apes are not related, even though they're separated by fewer differences than all your species within the felid family? Why do you conclude that? Well, it appears for a number of reasons that God has given animal kinds a greater ability to diversify, more design variation, most likely because they were created in bulk. This stuff's fascinating, guys. Great to see 24 people in the chat. So if there's any evolutionists in the chat, I mean, leave no stone unturned, right? You know, if you guys have any better arguments than the exception to the rule, or you think I'm not addressing anything, you know, I'm trying to address all the questions, because here's the thing. We have David McQueen come on, and anytime we have Dr. Carter come on, Dr. Sarfati, Dr. Stadler, we got Dr. Lyle coming on this week. We've got Dr. McKay coming on. We got McQueen coming on again. I mean, we're bringing all these PhDs on here. And what we do here on our stream is we keep it interactive. Okay, Dr. Sarfati, his interview was a prime example. I take all objections, questions from the live chat, and I ask them or present them to those who we are being interviewed with. And it's funny because we have David McQueen on for 2 hours debunking Gutsick Gibbon, but nobody from Team Dodgeball wants to be in the live chat to ask their questions, because then they have to ask their questions, provide their objections live where, you know, our guests can debunk it. But then they just want to go and do a damage control post. We'll probably get a damage control post on this. Well, probably not. The genetic stuff is usually ignored, but that's why we like to do these live. You know, I like to address problems live. We like our guests to address problems live. So that's why for Dr. Lyle, when he's here, you know, I mean, I told these critics, bring your best arguments against his, the one-way speed of light model. So anyways, and that's why we love our Dr. That's why Dr. Carter interview was awesome, because we asked all the most common objections and he addressed them all. Catherine. Yeah, Catherine, you have a lot of good questions. You know, I really like your honest and objective way of viewing these. So interviews we typically do earlier. Actually, good news. The Dr. Lyle one's going to be a little bit later. I think it's 7 p.m. Wednesday. But we would love you to be there too. Because the harder the questions we get in the live chat, the better. That's what we like. We like difficult questions. Okay, so we read through that. Here's another paper from years ago on this. Not this one. Right here. This is a good one. I highly recommend reading this one. This one goes into linkage disequilibrium. Okay, so here we go. You guys can still see? The Bible records a severe bottleneck 4,400 years ago in mammals, birds, and reptiles. Genesis 7, the flood bottleneck. We acknowledge this bottleneck. Followed by rapid expansions. Genesis 9:1, God's command to multiply, right? Animals migrated first. Your mammals, your birds, your reptiles, guys, they didn't have their own Babel event where they congregated and then their languages had to be confused. No, that was humans, further reducing their genetic diversity, but also explaining the origin of every shade of skin, the so-called races. After the flood, numerous organisms would undoubtedly have struggled to survive or totally become extinct, right? So there's going to be different scenarios for different species. Okay, survival of the fittest doesn't always mean the best genetically. A lot of times it has to do with suitability of the environment, who's reproducing the most, who's having the most babies. So different populations are going to experience different events, different history. You know, it's not a one size fits all. That's why it's difficult to make precise predictions within animals, right? Faithful, honest, and true. Good to see you. Catherine Stormgard, if you could make it on break, that's all. Good to know you're working hard, though. Keep it up. Okay, chat's good. Good to see. Good to see everybody's lively. So let's continue here. This is important. This would have been followed by yet another bottleneck specific to Homo sapiens at Babel. Just like I was saying earlier. Genesis 11, you can find that. As languages were formed and more expansion in humans would have occurred, organisms would have been created with maximum genetic variability. So let me read that again. Organisms would have been created with maximum genetic variability, right? We're looking back in time at the expansion of the genome. Evolutionists are looking back in time at the contraction of the genome. This roughly 6,000 years ago, and would thus still contain much more of this than assumed in a long age model. According to this framework, here we go, guys. This is key. This is key for your Swamidass who still doesn't want to correct himself. Dessel, Drace, you lasted a while, my good man. Thanks for being here, and thanks for helping us contact some intelligent design advocates. So Dessel's been a blessing. He's helping us out real good. So have a good night. Okay, so let's see here. So this is important. According to this framework, the least genetic diversity should be found within humans due to the Babel event. But isn't that funny that that's what we see? The critics are so desperate that Erica gets how many chances? Essentially, she got 3. She failed in our first debate at it. Then she did a straw man. And then she just provided an exception to the rule. Okay, so let's see. With greater diversity in what? Mammals, birds, and reptiles. And the greatest diversity in fish, amphibians, etc., which were not destroyed as completely as land animals by the flood. That makes a lot of sense. That's a good prediction. Additionally, organisms with shorter generation times would be expected to be more diverse as heritable mutations occur between generations, right? Doesn't that make sense? Shorter generations, more kids, more variation, like in mice, right? Versus, say, elephants. So, tempted to read. There's a lot of good information in this. We'll probably go through all of that one day. And here's Dr. Carter. Leave no stone unturned, guys. Make this yet another, as we say, irrefutable video. Okay, here we go. First, we need to consider pre-flood diversity. We have no idea how much genetic diversity existed among most animal kinds. Humans are, see, here we go. This is why they got to read the creationist literature. Humans are a little different because we know we started with 2, right? We know. I keep harping on that. We know how many humans God created. 2, Adam and Eve. We can make predictions. We would expect low genetic diversity, and that's what we find. It's predicted from the Bible model. Okay? And here's what's funny. These guys like Evograd, Dan, Pseudoscience Man, CRISPR, they keep saying that the Y chromosome data that suggests we come from one Y chromosomal ancestor, the mitochondrial DNA data that tells us we came from a female ancestor, the first woman, the mother of us all. They say, oh, this was expected mathematically from the evolutionary model. No, epic fail. Like, this is the best they got is your Dan, your CRISPR, Evolgrad. They can't even get that right. No, for one, they didn't predict it. And two, whenever they bring in coalescence theory, okay, they don't tell you about all the number of assumptions it makes. Because remember, now they're retrofitting the data. One of those assumptions I always harp on, and we got no rebuttal to it, is random mating, which is simply, it's just like random mating. So it's just like it sounds. You would have a population, and this population of people would all have a strong likelihood of mating and marrying. But that's not true historically, evolutionists. Humans have always existed in tribes. Those tribes have been separated. There's not random mating. The best rebuttals these guys have to offer on the genetic data are nothing but rescue devices based on bad assumptions. Okay, so here, humans are a little different because we know we started with 2 people and we know the population was reduced to 8 people 1,600 years ago at the flood. In fact, we can model, right? All of this has been modeled. We've got the human genetics to do it. We can model the genetic effects of the flood and the post-flood time period on humans. And then this is where we get right into animals. But we cannot do this for animals because we simply do not know the underlying population genetics. We cannot assume God created 2 of every animal. All we know is 2 of each were on the ark. And we do not know how closely related the pairs were. Even for the clean animals, just because there were more of them does not necessarily mean we should expect more diversity among them today, right? Just like Carter was going over in that video. This is for several reasons. First, clean animals tend to be cared for in flocks. Thus, they should have a higher level of inbreeding and less genetic diversity from the start. Second, some of them have been sacrificed or eaten soon after the flood. That's a good point too. Thus, reducing their numbers. We also treat each animal type according to their population history. Would we expect as much diversity in elephants as we do mice? No. The former has had a historically smaller population size and has been reduced to very small numbers in recent centuries. Guys, this is all empirical. This is all observable. This is real science here. And we have a starting point. And that starting point leads to accurate predictions, retrodictions, accurate data. They also have a long generation time. The latter has always been numerous and reproduced phenomenally quickly. Right? These are not just things we make up. I mean, we know this. This is recorded. This is direct evidence. Let's see. Thus, there are many species and subspecies of mice with many karyotypic, which just means chromosomal, differences among them. And we cannot forget that different kinds were created with different DNA repair and maintenance systems. It simply might not be fair to do one-to-one comparisons, right? It's not a one-size-fits-all. We also cannot discount the fact that some places in the genome are much more variable than others. And it's so funny because this was Dan's fatal blow argument, and we've just demolished it over and over again. Usually when an opponent, aka Dan, is claiming there is too much allelic diversity, they are focusing on those regions, example, the HLA genes. We must not forget that Lamarckian inheritance has recently been reintroduced as a viable concept. In fact, recent evidence shows that RNA is absorbed by developing sperm in the epididymis. Thus, acquired traits, the Weismann barrier, has been breached, and we can no longer say that strict Mendelian inheritance applies in all cases. This is important too, because a lot of times these critics will put forth an argument assuming an incorrect definition of allele. And I point this out with Swamidass and Dan. The definition of the word allele is also a problem. An allele can mean one of several things. If you are considering a single letter in the genome, there are at most 4 alleles, A, C, G, or T. But if you are considering an entire gene, there are as many possible alleles as there are letters to the 4th power. Given many generations, chromosomal recombination can lead to an increasing number of alleles because the initial versions of a gene get scrambled to make more versions. Finally, over 4,500 years go by. That is plenty of time to account for the accumulation of a lot of genetic diversity. Take humans. The bulk of our variation is biallelic and spread throughout the world. These variations are great candidates for creative diversity. Guys, another point to take from this, a lot of these questions and arguments in blogs, like that Peaceful Science blog that Swamidass, all they want to do is take you away from the real work and have a text war all day. Go like my Facebook page, but I've already got people. I've got one guy named Barry who keeps sending me on every post of his massive blog. I said, come debate me live, okay? We'll have your debate, 2-hour debate, and it'll be good. I'm happy to discuss your issues. And he wants me to spend, hours and hours a day in some blog war, text war, comment war over Facebook. I prefer the real thing, live debate where we can discuss these issues. And he said, no, he's not interested. He's not interested in it. Here's the thing, though, why those text and blog wars aren't even worth it, because they oftentimes show you what a waste of time it is, because the questions they asked, they could easily find their answer to just by going here. Look, there's over 12,600 articles and 800 videos. These have all been answered. But they want to suck you into some endless blog war. Then imagine I spent all my day in blogs and Facebook comment sections and didn't have a chance to actually make videos, write books, have interviews, discussions, debates. That's their tactic. Take us away. Take us away from the real work. These great interviews that people are loving, and just suck you right into the Facebook comment section all day. Like, listen, you got to think about that which is profitable, beneficial. Look at Swamidass, a militant critic of young earth creation. And he's asking the most simple questions, not even asking, putting forth a challenge and an argument that he thinks is just irrefutable that we haven't addressed. Just the most basic of searches. You can find it. So no, I'm not interested in blog wars, text wars. Let's set up a live debate. I've had about 100 of them, about 70 of them being formal on channels like Modern Day Debate, for example. So that's the best way to hash these out. Or else you're just going to be left answering the same questions all day in these blogs. Anyways, enough of the blog rant. I just find it funny. So here we go. These variations are great candidates. Oh, Raw Matt's in the house. Good to see you, brother. Good to see you. Always a pleasure. And there is no way to say that God did not front load Adam and Eve's reproductive cells with many different genomes, meaning that the genetic diversity of humans today may depend in part on how many children they had. Let's see. Yeah, so I mean, there's a ton here. Lots of good stuff. Y chromosomes, geographically specific. Allele frequencies. It's all consistent with our model. Now, here's the thing. If Erica was smart, she'd proudly proclaim her population bottleneck, the ad hoc, post hoc, out of Africa population bottleneck, right? Let me break this down, guys. Okay? If deep time evolution were true, and if anybody has any questions in the chat on what I'm about to say, let me know, because this is a fact. Okay, think about this, guys. Be objective. If deep time evolution were true, and we're evolving for millions of years, you got your Australopithecines, according to their model, you go to Homo habilis, okay? You go to Homo erectus, who now lives on this planet for millions of years, okay? You've got all these genes floating around, all these mutations building up, creating what? More and more diversity, more and more variation, okay? Let's say you had a population of erectus that was about 1 million. That's a lot of genes floating around a population of 1 million strong for however many years. So you'd expect from the evolution model high levels of genetic diversity. High levels of genetic diversity in the Y chromosome, the mitochondrial DNA. And what did we find? The exact opposite. We found low genetic diversity in humans. Every human, 99.99% similar. Every Y chromosome, every male Y chromosome on this planet, nearly identical. You can take every single Y chromosome, take the mitochondrial DNA. You can build some really interesting family trees. And you can trace them back to just 2 people within 6,000 year time period. None of this was predicted. Zero, nada, none of it. Because what was expected was the opposite. Now let's look at our model. We start with Adam and Eve. 2 people. It's only been 6,000 years. It's not a lot of genetic diversity. And yet that's what we find is low genetic diversity. Exactly what we expected. Didn't have to retrofit anything. But now here's the thing. Even when they want to invoke their population bottleneck, okay? They invoke a couple population bottlenecks. Some of them believe there's a population bottleneck 70,000 years ago due to a toba extinction, reduced genetic diversity. You got a lot of evolutionists contesting that. That was Erica's argument in my first debate. Then you could see CRISPR, who they look to, saying, oh, no, there probably was no population bottleneck 70,000 years ago. Toba extinction probably didn't do that, wasn't capable of it. Okay. Then some invoke a population bottleneck within Homo erectus population. 200,000 years ago, maybe, whatever. But they need a way to reduce levels of genetic diversity. But here's the thing. That type of population bottleneck in the evolutionary story, it can't be for one generation like ours. Can't be for 2, can't be for 3. It's got to be for 1,000, thousands of generations. They don't have a number. You can't really find a number. They don't know. And I'll tell you why. Because it's going to take a long time to reduce whatever that current genetic diversity was, whether it was in erectus, early Homo sapiens, whatever. There would have been a lot of genetic diversity that would have had to been reduced. So that means you would have had generations after generations of what? Inbreeding. That's what reduces the genetic diversity. Now, here's the thing. Those mutations that are hidden in recessive form, they're all manifested. That's what inbreeding does. Inbreeding, guys, is a sneak peek into where we are going genetically as a species. Inbreeding reveals the hidden reservoir of genetic mistake. They come to the forefront and they lead to rapid and accelerated genetic degeneration. And we're supposed to believe that out of this disastrous population bottleneck, modern man evolved, and now we're flying in airplanes. We've built the space shuttle. I'm streaming here over StreamYards to people all around the world. Through a disastrous bottleneck of significant and severe inbreeding that would have been disastrous genetically, all of these deleterious mutations coming to the forefront, leading to rapid and accelerated genetic degeneration. Not even remotely plausible, not even remotely feasible. Never an answer had been given to that. We know what bottlenecks do. Look at the cheetahs today. They're down to 7,000. They're not going to suddenly spread out all over the planet, seizing dominion over the world. Not going to happen. But they want us to believe that that's what this population of 2 to 10,000, some say 30,000, did 70 to 200,000 years ago. No, not going to happen. Not plausible. Rescue device, storytelling. I asked a couple guys this question in an after show on many debates. This one comes to mind, though, as an interesting one, especially because I know David Neff. He's been battling us for a while, and I respect his willingness to debate and dialogue. I need to go upstairs and get some water. So I'm going to play this video at 1.5 speed just to give you guys an idea that it's not a question that can be answered without invoking rescue devices, stories. there, especially in debates. Dr. Dan, for example, we're discussing ERVs and other classes of retrotransposons, and he goes into the minutia and says, "Oh, you're wrong. ERVs are not a subclass of retrotransposons." Just kind of wasting time on such a minute detail, when in fact you can find paper after paper, source after source that directly states ERVs really are a subclass of retrotransposons. And then I show that to him, and he says, "Well, yeah, some people think that, but there's debate among scientists." But my whole point is, something like that is just a complete waste of time. It's avoiding the actual key issues, the bigger picture, and I do find that a lot debating evolution. I'm not saying you're like that, Ogre, but I've personally encountered that many times.
So I feel you guys, believe me, I do. When I watch debates on other channels as well, it always gets dragged through the mud. No one likes that. 100% agree with you. The reason I brought up the bison question to Neff was because it was about the genetic bottleneck, right? And the argument that David was making is, if the population gets too small, it can't grow again without genetic problems, right?
Yeah, well, that was part of my issue. And if you have all the genetic everything, all of life bring it down to 2 or 7 individuals, you'll go pretty quickly. I mean, the problem is you're not going to get the hyper rapid evolution that the blood model is going to require. If you're going to need to get all the extra diversity within a couple hundred to 1,000 years maximum after the flood. You simply can't do that if everything was reduced down to only 2 individuals. You would end up having to create several dozen new species each day to create the extra biodiversity that is represented in blood just very shortly after the flood.
Yeah. And I guess, this isn't my field, right? I deal with rocks. Living things suck. I hate them. I never studied them. But I'm sure there's a number that a population can get down to where there isn't a problem where it is, right? I think cheetahs have that issue, where the cheetah population got so low that they have these issues with defects, right?
Yeah. That's
well, what's funny about that is your cheetahs right now are down to, like, the last time I checked, they're down to about 7,000. They're highly degenerate. Conservationists are incredibly worried about them. They were at 10,000 at one point, but they're incredibly close genetically due to inbreeding, due to a severe bottleneck. And I always bring it around to, because oftentimes the critics, they will say that biblical creationists have a bottleneck problem, when in fact your very own out of Africa scenario, which suggests that there was a population bottleneck of between 2 and 10,000, not for 1 generation, not for 2 generations, but for thousands of years. We know that would result in the fixation of many, many deleterious mutations that have accumulated for millions of years. You got the Australopithecines evolving into Homo erectus into Homo sapiens, and then you got the bottleneck. So how, according to your model, why would we believe that extremely genetically compromised population of, say, 2 to 10,000 that would have been so highly inbred, how did they suddenly explode in all parts of the world, seizing dominion over the planet, like the out of Africa scenario would suggest? So my point is, it seems like the evolutionary story is the one with the inbreeding problem.
So let me point out something real quick before he answers that. I pasted in the side chat the source that I used for my discussion about bison. It comes from it was off of Wikipedia, citation in Wikipedia, which states in North America in the early 20th century there was less than 100 bison living on the continent. So I just point that out.
Yeah, I saw that. Thanks, Neff.
Yeah, I found another paper from, like, the intertribal bison something or other. They said it got down 200, like below 250 was another one I found. Yeah, the numbers are probably going to vary. I think if you study evolution theory, you'll find the genetic diversity of creatures that live in this world, you find that it's genetic diversity is going down. Everything on this planet is moving towards extinction because of the accruing mutations, especially single nucleotide variants that are affecting protein codes and adding diseases left and right to human beings and everything else. We're all going extinct. That's the opposite of evolution.
Okay, so this is kind of like where I wanted to go in the after show, because I know Stephen and I were kind of discussing that in the chat. Same Patrice said that 300 generations is the maximum time frame before we wipe ourselves out naturally due to the accumulation of protein mutations, correct?
Well, I mean, if human beings have been experiencing random mutations for the time that the evolutionists believe humans have existed, just humans. I mean, we could apply the same reasoning to every creature that came before every creature in the evolutionary tree, the imagined tree. Then there simply would be no evolution. No organism can exist for tens of thousands of years, accruing mutations at the rate at which human beings do. It would simply rewrite our genomes with thymine. Because the majority of mutations, the single nucleotide variants replace, when a replacement of a base nucleotide occurs, more often than not always, but more often than not, it's replaced with thymine. So over a period of 50 million years, a very large percentage of the human genome should have been turned into nothing but thymine. Instead of cytosine, guanine, and all the base pairs, we should have massive numbers of thymine in there, just corrupting the heck out of our genome and making us unsuitable for survival. So the evolutionist believes that mutation is this fantastic designer of unfathomable complexity and efficiency and function. But real science shows us mutations are destroyers. So evolutionism is pseudoscience in denial of what the actual scientific data shows.
Well, not only, and David, and Ogre can, and I know it's not your expertise, Ogre, but my question about the out of Africa scenario, because you and I, David, we discussed this in our debate a few days ago on the origin of genetic diversity. And as you know, evolution explains the origin of all DNA differences, all genetic diversity as the result of mutations over time. And then natural selection acts upon that variation. So here's the thing. By the time you reach that out of Africa event where you have that very significant population bottleneck, mutations have been accumulating for millions and millions of years. And now, as we know, by definition, inbreeding exposes the hidden reservoir of genetic mistakes. Those mistakes that have been accumulating, they're in a recessive state, they're now manifested, and they lead to rapid and accelerated genetic degeneration. So, David, how do you explain how that's remotely even plausible in the out of Africa event because of the significant inbreeding? Can you answer that question, David?
But before David responds, Zach Brannigan, as usual, is an idiot.
So here's the thing. It's almost like a light bulb goes off when you bring that up to the evolutionists, because as I stated, all of those generations, millions of years essentially, as I was explaining earlier, we've got your Australopithecines evolving into Homo erectus eventually through incremental changes, descent with modification, okay? These mutations, based on what we know today, are deleterious. Random changes in the nucleotide sequence. Not good, not good. Most of them so subtle that selection cannot remove them. So by the time they even have their bottleneck in the out of Africa scenario, guess what? They've got a ton of mutations. A ton of mutations that have accumulated. Which means all of those mutations are now going to come to the forefront. And they are going to destroy. Not to mention the reductions in heterozygosity and the increases in homozygosity. It's not good for the population, especially with those mutations coming to the forefront that we're in a recessive state. Not good. And that's why David here is going to have a lack of an answer. It's not even his fault. It's like trying to explain the impossible.
As you can see from his chats. Well, I just realized we were wrong all along. It's not the atheist world we were terrifying. It's the Christian one. We're all going extinct and dying because God got mad we ate an apple. Good night.
Yeah,
Zach. Well, Zach, as usual, your dumbass seems incapable of comprehending the premise that you have an immortal soul that can live for eternity and not have to worry about going extinct. So I don't really know what's terrifying about the premise of immortality and not being bound by the limitations of the current version of the mortal coil. That to me doesn't actually seem all that terrifying. It's actually kind of cool. It's just a matter of actually opening your mind to the bigger picture and not being so myopic in your worldview. Now,
well, he could get the gift of eternal life from Christ if he wished to, but he doesn't want to do that forever.
Yeah, now, David, sorry for my little diatribe there. Go ahead and respond to SFT's question.
Can you repeat the question again? I'm sorry, I got it.
Well, I got to say, I think I repeated it twice.
David, the connection.
It's the same question. Hey, David, I asked you that question, I think, in every one of our previous 4 debates. So here, I'll make it quick. How is the out of Africa population bottleneck even remotely plausible due to all the enormous amounts of deleterious mutations that have been accumulating? They are now manifested. And as we know, the out of Africa population bottleneck wasn't 1 generation, wasn't 2 generations. It's hard to find a number, but it's at least more than 1,000 years in order to reduce levels of heterozygosity, because they invented that hypothetical out of Africa population bottleneck. Why? Because when they discovered that humans have incredibly low genetic diversity, they were shocked. They did not predict this. Therefore, they hypothesized that there must have been an incredible bottleneck in the past that would have reduced genetic diversity, but that would have resulted in incredible genetic damage. So how is that out of Africa scenario even remotely plausible? David, go ahead.
Okay, yeah, this is something I'm going to be working a video on.
David, you guys speak up. I can't hear you.
Okay, is this any better?
A little bit.
Yeah, I hate I'm not deflecting or anything, but I am going to make a video about that. But it's 12:45 ish almost, so I'm just going to kind of doze off. And
well, David, instead of making a video on it, can you just see? Here's the problem: we're looking at the cheetahs today, and we know what bottlenecks do. Okay, and here's the thing: I debated a biologist on it, and he was kind of thrown off as well. So I don't know if you could have a better answer than a biologist, but we know by definition, inbreeding is not a good thing. And the more deleterious the mutations are based on how functional our genome is, if the majority of mutations are deleterious, that means those 100 new mutations per person per generation that are accumulating are degenerating our biological information systems a lot faster than we ever thought. Therefore, David, if those nearly neutral mutations are invisible to natural selection, we know natural selection acts upon the best beneficial mutations, gets rid of the worst detrimental mutations. But my question to you is, what type of selection can you provide us with tonight that can remove so many slightly deleterious mutations that are pouring into our genomes generation after generation, David?
So are you talking about like the mutations like the sickle cell anemia that have like a double-edged sword where it can be beneficial but not beneficial as well? Is that what you're kind of going at?
No, he's asking you what genetic mechanism saves us from the mutation rate.
So check out Genetic Entropy Part 1, guys, as well, because that's the problem. All of these mutations pouring in from generation to generation. We are consistently getting more and more mutant, just like we are in our own lives, okay? There's genetic entropy on a personal level and genetic entropy on a population level. But if these mutations are accumulating too fast for selection to ever remove such mutations, and if selection is only a fine-tuning mechanism, keeps the species as strong as it can be, acts only upon the worst deleterious mutations, amplifies only the best beneficial mutations, why can they never provide us with a type of selection to remove all of these mutations that are just so subtle, like single spelling mistakes in a book the size of an encyclopedia? One single spelling mistake in that book the size of an encyclopedia, inconsequential on its own, but over time, as they accumulate, they slowly degrade the message to the point where the book's unreadable, just like our genetic information system. We're degrading. These mutations are destruction. And you can go watch our video titled Gutsick Gibbon Takes the Abiogenesis Challenge, where for 2 hours we discuss these issues, including that. And I was asking James in there the question. I was asking a number of evolutionists that were in there. No answer given. No answer given in this 3.5-hour video. Yeah, they've got rescue mechanisms like synergistic epistasis, mutation count mechanisms. We've shown how those have been falsified. These are artificially contrived, especially the mutation count mechanism. Synergistic epistasis only makes it worse. Check out Genetic Entropy Part 1 from a few days ago. We went over all their rescue devices, the so-called trade-off. We addressed that. Dan likes to say that we haven't mathematically shown this. I showed how that just proves that he's not worth talking to. Showed a number of papers. Mendel's accountant, for example, is you could throw in any number of parameters, you could throw in purifying selection, super beneficial mutations. It doesn't matter. The data always comes back showing that genetic degeneration is inevitable. We've addressed the claims that they've made on junk DNA. So that video addressed all their arguments for this. It's now at the point where the critics who deny the reality of genetic entropy are just denying reality.
Well, of course, natural selection is what would.
Well, that's what he's asking. How is that work?
Yeah. Because I'm telling you, I'm pointing out that everybody agrees natural selection keeps a species as strong as it can be. It's a fine-tuning mechanism. Natural selection, better understood as differential reproduction, who's reproducing the most. Natural selection will remove the worst deleterious mutations, okay? It can see that. And it will amplify once in a while a beneficial mutation that is context environmentally dependent. Oftentimes they're reductive. For example, like sickle cell anemia, yeah, it's got a significant benefit, significant impact, but it's due to a broken cell, broken protein, broken gene. It's reductive, not taking things forward. So the question is, those slightly deleterious mutations that are kind of like a single spelling mistake in a book the size of an encyclopedia, you can't see each one on its own is inconsequential, but it's the buildup of them over time that degrade the book, the message in the book, and in biological information systems degrades us slowly, like rust on a car. So what type of mechanism, David, can you provide us with tonight that can get rid of these mutations that are deleterious pouring into our genome?
Yeah, I'm not quite sure off the top of my head. Again, I am going to bed pretty soon.
The important point, the really truly important point that's
Hey guys, and we appreciate David. He's always so open to discussions, dialogue. But I just wanted to point out that John Maddox put out a video last night where he was asking David the tough questions. David was getting the tough questions, and his response was also, I have to go to bed now. And see, here's the thing. The evolutionists, they want to go to bed after being asked the tough questions. I'll tell you why. They're hoping so badly that they'll dream up an answer. Dream up an answer. They'll wake up in the morning and say, finally, I've got an answer to how we can solve the problem of genetic degeneration and mutation accumulation. But the reality is, guys, they never do wake up to an answer. They wake up to reality. another day where they are more mutant than the day before it. And they could do nothing about it.
Standing for truth is making is that natural selection can't see anything except the worst mutations, the most destructive. It does not see the vast majority of mutations. They're invisible to natural selection. Reproduction passes on mutants, entire mutants with all their mutations. The only ones that are going to become so unfit to survive are those that receive a mutation that makes them so degenerate that they won't be selected for breeding because the mates won't accept them, or they just are so ridden with disease that they don't survive. So natural selection can't see the vast majority of mutations.
I got a question on this topic, if you don't mind.
Yeah.
This is not my area, David. If I start going off track, let me know. Right, I play with rocks. But Neff, you seem to be talking about mutations as in like the big ones, like I'm born with 3 feet and none of them works on mutation.
No, I mean all kinds of diseases.
Well, but you said mutations, it gets rid of the bad ones. I'm
right.
just quoting you here.
Well, the worst.
Isn't mutation something that like technically a mutation is just any particular change over time, right?
Right. So what is the effective?
Is the argument you're making that with the genetic bottleneck standing, is the argument you're making that we eat those little teeny mutations with twofold of those? Is that what's going on here? Or
yeah, because the majority of mutations are nearly neutral. The beneficial mutations, according to Lenski's experiment, they're incredibly rare, but 1 in a million. Sure. And then the incredibly detrimental ones, we've kind of removed natural selection as a human population. We take care of the sick. But in the wild, if an animal is born with an incredible defect, it will die. Natural selection will remove it from the population. It's not going to reproduce, right?
Or breeding selection. It won't be selected as a mate because the other members of the population will see it as defunct and they'll reject it.
Oh, good night.
Yeah, take your time, Wilbur. We've been talking a lot. I was just trying to get an answer to David, but he's tired, and that's fine.
Yeah,
so,
well, I mean, I'm just trying to. I'll do the best I can here, completely off my basis, but I'm trying to get. I want an understanding of your point. That way, I can think about it correctly, right? Strongmanning, I think it's called. So that's what I'm trying to ask. That's why I'm trying to ask you these questions. So, standing, the argument for the bottleneck issue is the humans, when they left Africa, accrued so many negative mutations, teeny ones, that they should have died off. What?
In Africa, they say Homo erectus. Well, according to the literature, there was 2 out of Africa. A subgroup of erectus left. They would have independently evolved into like Neanderthalensis, Heidelbergensis, Naledi, Floresiensis out of Africa. Because the problem was when modern Homo sapiens left Africa, it was a big surprise that there were other people groups. They ran
into them in like Europe and stuff. Yeah.
Right. Yeah. So there were people groups outside of Africa. But the thing is, modern Homo sapiens evolved from erectus in Africa, but they didn't leave Africa until they experienced a severe population bottleneck that would have decreased levels of genetic diversity, because we know humans today are 99.99% similar. So therefore, the scientists, they look to this population bottleneck to explain that. But here's the thing. It wasn't 1 or 2 generations. It was similar to the cheetahs. Therefore, that hypothetical population, some say 2,000.
Okay, I get the connection you're going. So we know cheetahs, we know bison, to throw it back, have these problems in the genetic code. Why don't humans have that same problem? Is that the statement?
Well, no, it's in the out of Africa event, that population of 2 to 10,000 would have been so genetically compromised, comparable to the cheetahs we see today.
Yes.
Therefore, this is what the evolutionists say we came from. The out of Africa scenario, we came from Africa. But that population would have been so genetically compromised. There's no feasible way that they could have suddenly exploded in all parts of the world, seizing dominion over the planet, because they would have assimilated So in your opinion, or how is that plausible given how genetically damaging that bottleneck would have been? Go ahead.
All right. So again, no expert, right? But I would have to make the assumption. You know what? I'm not even going to try here. I play with rocks. I don't know. I don't know all these processes. I can't even take a go at it. Sorry.
No, it's definitely something worth looking at. I've debated, you could see some pretty in-depth discussions with some biologists I've had on this one. It is an issue. Well, and that's the thing, even with the 1 Y chromosomal line, the 1 mitochondrial DNA line, we know mitochondrial DNA has incredibly low variation worldwide. The Y chromosome, same thing, which demonstrates that our genome is young. But the evolutionists, of course, they don't conclude that we are young as a population. They have looked to this population bottleneck to reduce levels of genetic diversity. And as a result, now we are stuck with 1 Y chromosomal line, 1 mitochondrial DNA line. But what's funny is this is exactly what the Bible would predict. 1 Y chromosomal ancestor, 1 mitochondrial DNA ancestor, low genetic diversity. So we don't have to invent fancy stories. This is exactly what we'd expect.
Right. The genetic data actually supports the biblical account.
So I know your history.
So here's the thing, and here's why I don't think Gutsick Gibbon discussed this in her video, apparently refuting us, is the fact that they did not predict the levels of genetic diversity in humans. They had to resort to a population bottleneck to explain the levels of genetic diversity. But when they resort to the population bottleneck in their Out of Africa story, that is a post hoc ad hoc rescue device. It only results in more questions, more problems, more challenges. The biggest one being the fact that that population bottleneck would have been disastrous. Disastrous to the point where it's nothing more than a rescue device and a fairy tale. Evolutionists hope, dream, and imagine. Guys, Erica, today, she's hoping, she's dreaming, and she's imagining that modern man, capable of building the space shuttle, can evolve out of population bottlenecks that are disastrous to populations, disastrous to genetics. Okay? If only these evolutionists would admit that they have a story, they have a religion, they have a belief system. It's when they prop it up like it's science, empirical science, observable science. They want to brainwash you into thinking that this is actually science. It's not science, okay? This isn't the type of science that has led to our cell phones, the laptops, the computers that we use on a daily basis. No, this is fairy tale science. This is imagination. So, I mean, I think tonight's been pretty clear. See what we got. What else we got here, guys? It's been a couple hours. I'm getting pretty tired. I think this is going to be worth it for you guys. Let's leave no stone unturned. So this is a clip from a debate Raw Matt and I had with Adam Heap. Good guy, funny guy, zoologist, herpetologist. His question, and this is what's funny. The evolutionists don't think about these types of things. He asked us, if you could jump into a time machine, where would you predict? Let's say we jumped into a time machine and we jumped, I can't remember exactly how many we'll see here, 100,000 years from now, what would you expect? But it's just so funny that doesn't even dawn on them. That is such a good question, because we'd expect what? Extinction, further degeneration. So let's listen to a bit of this one. I thought this was interesting. And that's the thing. Evolutionists always want to invoke time. Erica, in our third debate, she kept trying to appeal to time because she couldn't deal with the genetics. She wanted to go to rocks, right? Just like Org there. And I like Org. Nice guy. I've seen him point out to some of the other evolutionists in after shows and streams, point out some bad atheist arguments and say, hey, maybe we shouldn't use those. Maybe we shouldn't straw man the creationists. So he's one of the more objective, I think, viewers in all this. So we appreciate him. Doki Doki, thank you so much. Doki Doki's got the rainbow and the super sticker. I appreciate it. So let's watch this clip. These were a good set of debates, guys. They're from months ago. The first time I debated Adam was over a year ago. Nice guy from Britain. Like I said, zoologist, herpetologist. I don't think he's actively working in those fields anymore, but he's got degrees in them. Matt and I did a couple debates with him on these topics. He wanted to debate our model and the content in our books, and we did it. We took the challenge, went on. First one was on Modern Day Debate. Second one was on my channel. And guys, I want to point out, watch Raw Matt and Erica's debate that they had on my channel, on this channel, Standing for Truth, where Raw Matt brought up that study, the Rockefeller study, where they discovered low genetic diversity in the CO1 gene, that highly, highly conserved gene in the mitochondria, showing that over 90% of all species originated at the same time, consistent with our model. Now we've got humans and animals, all consistent, all demonstrating biblical creation. So let's listen to this one real quick for a bit. But yeah, check out that video. Erica didn't have a sufficient answer to that. Nobody does. They have to just retrofit as usual. Selective sweep, bottleneck, right? In other words, sweep the data away, retrofit it into the evolutionary story. Don't question the bigger picture.
say you had a time machine and you zoomed forward in time, assuming the Earth was still around at this point, fast forward 100 million years, what do you think life would look like?
So if we fast forwarded 100 million years from now, well, I think that's actually a good question because, accumulation, right? I mean, we know we inherit about 100 new mutations per generation on the known of the genome. Most of those are deleterious. So if I were to look 100 million years into the future, I would see extinction, because that's exactly where we are heading, since there's no type of selection that can remove all these deleterious mutations.
You said there that most mutations are deleterious.
Yes.
That's not true.
Well, it's true because
most of them are neutral.
Well, I mean, according to the assumptions of evolution, most would be neutral, but that's just because evolutionists assume that the majority of our genome is based on evolutionary leftovers, junk DNA, genomic fossils. But that's actually a direct prediction of the created heterozygosity hypothesis that would suggest that the vast majority of our DNA elements, for example, ERVs, ALUs, and these other classes of retrotransposons, would be functional. And that's exactly what we're now seeing. That means the more functional the genome is, Adam.
Can I just ask quickly there, did they make that prediction before we found that out?
Yes, intelligent design advocates have always predicted genome function increases in levels of genome function. That's why the evolutionist community attacks the findings of the ENCODE project, because the ENCODE project has shown that most of the human genome is functional, and not only that, but functional on many levels. I mean, we have layer upon layer upon layer of programming within the genome. Are you familiar with all the known functions in these retrotransposons and in the endogenous retroviruses and pseudogenes?
I'm not familiar with every single one, no.
So Dr. Nathaniel Jensen, in his model of created heterozygosity, and that's why I asked you to clarify your understanding of where we explain the origin of the vast majority of genetic diversity, for example, in the nuclear DNA, because it's two opposite expectations and predictions. I mean, how much of our genome, on a percentage-wise, both protein coding and non-protein coding, would you say is functional according to your model?
According to my model, I don't know. I don't know the number, unfortunately.
Well, it is very low. Like I've debated PhDs on this, and they have to assume junk, for one, in order to counterbalance the mutations that are building up in the genome, because they need to assume that they are neutral, that they're not actually damaging the genome. But even if, and it's funny because the evidence suggests that we have a genome of function, but even if, just for sake of argument, just to not discuss this topic forever, even if I said, okay, let's pretend that the genome really is 90% junk, that still means that's 10 new deleterious mutations that are pouring into the genome per person per generation, and most of those being unselectable, because natural selection, Adam, only acts on the most detrimental of mutations and the most deleterious mutations, but it does nothing against the nearly neutral mutations. Those are invisible to selection. So my answer to your question, if we were to go 100 million years into the future, it's a very simple question. I mean, life would not exist. And I guess you would have to explain how natural selection can keep life in existence for that long. Go ahead.
Yeah, you talked about genetic entropy. Now, I looked up genetic entropy, and the only places I could find it on Google Scholar were creationist sources, specifically from John Sanford. And all the examples I see are very specific species-specific examples, mostly humans. Now, the problem with humans in the natural world is that we've sort of done away with natural selection. So, yeah, deleterious mutations are more numerous than beneficial ones. So over time, if there is no selection pressure, you'll have more of a buildup of deleterious mutations. However, natural selection in the wild, assuming that it's able to do what it needs to do, will prune the wild populations of deleterious mutations and keep the positive ones. So that's how you maintain populations. That's what natural selection does. It gets rid of the bad and it keeps the good, what's fit for the environment that the creature is living in. That's how populations are sustained, and that's how they have been sustained.
Right. I really appreciate that response, because you made some good points. I just don't think that you've addressed the nearly neutral mutations that would build up, because the same thing goes, and I don't want to take all the time. I know Matt has some good examples of genome degradation, and health, for example, is kind of his specialty. So I'll let him take over in 1 second, but I do want to point out the fact that, in humans, so obviously you're admitting that we are degenerating, but you are saying that it's due to a lack of natural selection, right? Which makes sense, but it would come down to, let's say, animal populations. It would still come down to genome function as a whole, because even in animal populations, they still have to assume that the majority of the genome is junk in order that the junk areas can absorb the mutations, making them neutral. But the fact is, Adam, and you have to address it, is the evolutionist has lost one of their favorite pieces of evidence, which is not only junk DNA, but also the presence of these ancient deactivated viruses that they say are in the genome. Because rather than being functionless vestigial remnants of our past, these retrotransposons, as a direct prediction from our model, turn out to be functionally integrated into the amazingly complex regulatory genetics and genomes of mammalian genomes. So that means that total functionality with all these DNA elements, DNA sequences, will speed up and make the degeneration problem that much worse in humans and animals. Take your time.
I am very curious, because you keep saying that intelligent design predicted. Who predicted it and when?
So there have been predictions in the past. I can get you specific names. For example, Dr. Jonathan Wells has made those types of predictions. Dr. Nathaniel Jensen has in print right now new predictions that the vast majority, over 80% of our genome, because ENCODE, they did what's called biochemical tests, right? So Dr. Nathaniel Jensen predicts that using genetic knockout tests will reveal exactly what types of functions these DNA differences have. Because if we predict that the vast majority of DNA differences are actually functional, Adam, that would be evidence for that exact hypothesis. We're seeing that with the overturning of the junk DNA. I mean, what was called junk DNA, we now know can modify the way chromosomes, right, the packages of DNA are organized. And then what that does is it changes the way the DNA functions. It's DNA function on multiple levels. I mean, how do you
non-coding areas of the genome do exist in large quantities. And in fact, it's one of the ways that you get de novo genes, which explains orphan genes. So for example, a study recently looked at cress, several species of cress, and they found that these lineage-specific genes, what they call orphan genes, were actually just mutations of non-coding DNA that didn't do anything in other species of cress.
Right, and that's the assumption. So
no, it's not an assumption.
I understand that, you know, the explanation for these taxonomically restricted and essential genes is de novo gene synthesis. I'll address that in a second, but I wanted to point out that if the genome truly is junk in the non-coding region, most of it, you know, has no active role. But then the ENCODE project has revealed that over 80% of it is actively transcribed into RNA, and the evolution say, well, that's just biochemical testing. But my question to you would be, if it truly was junk and there was no useful activity there going on in the non-coding regions, why, Adam, would the cell even bother with it? Because wouldn't you agree that that activity that is discovered would be just a waste of energy and resources, and natural selection, which we were talking about earlier, should have eliminated that junk long ago, according to evolution? How do you answer that?
I'd have to look into it more. I couldn't answer off the top of my head without sounding like a complete dunce.
No, that's okay. I mean, I do want to pass on Matt real quick because his expertise on health and genetic degeneration, I wanted him to at least point out a few
I would
examples.
like to just interject something here. I would like to eventually get back to kinds, because we keep drifting back to evolution stuff, and your idea is to disprove evolution.
Well, no, it's not disproving evolution, because and I know that the assumptions and basic worldviews of evolution, it's hard to you know, put themselves into the mindset of a creationist, because what we're saying is that the vast majority of DNA differences were the result of divine creation, and evolutionist says it's mutations over time. That means we have two very different expectations and predictions on ancestry. You would expect you know, a genome of junk, evolutionary leftovers, and genome of fossils. We would expect a genome of function and DNA elements. That's what's going to help us determine whether or not everything's related, or whether or not limited ancestry, according to the Bible, is what's true. And that's exactly what we're pointing out here and demonstrating.
Okay. So what could you explain then why every creature, if you test them genetically, comes up into this well-defined tree?
Right, and that's a good question. You're going back to the nested hierarchical patterns, the groups within groups patterns that we see in life. And as I pointed out in the beginning, the design model predicts and expects the exact same thing. That's why we have to look at differentiating evidence, which would be function. How do we test, you know, for ancestry? It would be function, a genome of function versus a genome of junk. But like you said, let's go more into kinds and more expectations of, you know, speciation from, say, the original kinds. Because I know that's what you want to talk about. I think that would be enjoyable for the audience. But can we just reserve just 1 second for Matt to jump in and make a point about genetic entropy, and then we'll go right to kinds and definition of kinds and things like that?
Yeah, that's absolutely fine with me.
All right, I'll just get it over with real quick. A perfect example is a video that I made which shows Neanderthal. It shows that they have less overall genetic mutations in their entire genome, and today we have a lot more. We also have something called the MTHFR gene, and it's broken anywhere between 40 to 70% in almost all people on Earth. And it's that gene determines on how well you methylate, how well your other genes work, and how good they are. So it kind of shows a genome collapse by looking at that. But you know, that doesn't really have much to do with kinds. It's just an overview of showing that the genome is kind of crumbling and breaking down. We see gene loss. We don't see new genes arising in our genome going up. We see it going down in all life. So
I will just put a point on that. We do see genes arising. I mentioned the cress earlier, where they identified many non-coding sequences becoming de novo genes. So we do see increases in genes. We also see anatomical increases, which are results of genes. So for instance, dogs, more primitive dogs, wolves and huskies, don't have puppy dog eyes because they lack two muscles around the eyes, whereas more recent breeds of dogs have these muscles. And that is a result of mutations that came about to benefit dogs that live with us because we love puppy dog eyes. I think that's a beautiful example of evolution in action that happened during human history.
But these de novo genes that are arising spontaneously, kind of like out of nowhere, that really are considered junk DNA, are actually functional elements. So we can't just say that these are randomly arising, but yet these de novo genes are absolutely required for functions in the in the body. If they were just, that's what makes the orphan genes so fascinating, is because they're lineage specific. So it also helps prove our model a little bit, because they are taxonomically restrictive genes, but they're also functional elements, which Sandy mentioned earlier.
The fact that genes become active from non-coding genes, I don't see how it proves your point. I don't see how it lines up with it.
And I like your point on orphan genes, Adam. But we would just have to see actual, you know, papers that are showing a non-coding region of our genome suddenly popping up and having an incredibly functional role. Because
if you look at the one on cress, it was quite recent. If you look at cress de novo genes on Google Scholar over the last, I think it was 2016. If you look at, there's about 500 de novo genes that come up from non-coding regions.
And we have looked at many papers. I just want to put this out there, is that in what you're saying, just to reiterate, these orphan genes were created supposedly from just random mutational events in the non-coding regions, and they've now co-opted function in the protein coding regions. They're not, right? Is that how you would explain the orphan genes?
We see the non-coding regions. The reason we didn't see them before is because they were non-coding, so we didn't really know what we're looking for. But when we found these genes in this certain species of crest, we look back at other species of crest and check for that same sequence and find that it's a non-coding region of the DNA.
Well,
I'm saying crest. I'm assuming you think crest would be within the same kind.
Well, and I'm just saying, I'll give you plenty of time. I'm just saying that because evolutionists reject this concept of engineered design in biological systems, when they see the presence of these taxonomically restricted orphan genes, they have to come up with a way as to how these cleverly, designed DNA sequences were somehow randomly generated in very recent evolutionary time. And you look to de novo gene synthesis, but my response to that would be that it's based more on a circular argument, because evolutionists say, okay, de novo gene synthesis must be true because why? Orphan genes exist, and orphan genes exist because of de novo gene synthesis. So I don't know how
there are various methods for not de novo genes, orphan genes. You've also got things like fission and fusion of genes. You've got gene duplication and exon shuffling off the top of my head.
Right. But a lot of times in these papers, for example, one that I myself are really familiar with are the so-called introduction of new orphan genes in fruit flies. Matt, did you want to touch on that real quick? Because orphan genes, you must understand, for one, could be lost as well, which could explain why you're seeing some in some species in the same kind that other species in the same kind don't have. Did you want to touch on that real quick, Matt?
Yeah, real quick. They took fruit flies and they looked inside of their orphan gene status, and they wanted to try to get them out. So what they did is they bred fruit flies, a specific species of them, to have 0 orphan genes in their bodies, just to see what would happen. So they bred them entirely out after maybe 10 generations or so, completely gone. So the flies were living without any orphan genes in their body.
Okay, I just want to make a correction. I said 2016 for the crest paper. It was actually 2011.
So as you can see there, guys, the whole debate's a must watch. The 2-parter, I think, is close to 5 hours long. You can find it in my debate playlist. Adam and Eve, the great origins of species debate, I think. Check it out. Here's the thing, though. You can see just from that 20-minute clip. You can just let it play out. And we like Adam Heap. It's not his fault. But guess what? This is the typical... This is what we see with evolutionists and the critics and their talking points, right? The junk DNA. The junk DNA paradigm is dead. They don't have the junk DNA anymore to explain away all these mutations that are deleterious, okay? No, they're not neutral. There's no way really to prove a single neutral mutation. They all must have some effect on genotype, okay? And the more functional the genome is, the more deleterious these mutations become. And we talked about in part 1, and I'm not going to reiterate it all for sake of time. We're going on 2.5 hours here. But the fact is that even if the genome was only 10% functional, and yet we have evidence for between 60 and 80% functionality, even if it was only 10%, that's still too much for ape to man evolution. None of these questions addressed by Team Dodgeball. They duck, they dip, they dive. They dodge all over the place, guys. It's bad for them. It's really bad. And that's why whenever you ask them, how much would you predict, or what do you think in terms of functionality? How much on a percentage-wise do you believe the genome is functional? And typically they don't want to put themselves on the line and make a prediction. They can as evolutionists. They're hoping for junk, to be able to just wave away the genetic degeneration problem. Here we go again, guys. Dodge, duck, dip, dive, and dodge. No mechanism provided by any of these critics. Okay? They don't understand the fact that natural selection is getting rid of the worst detrimental mutations, the most damaging. Yeah, we agree that natural selection is a fine-tuning mechanism. So, guys, this has been a lot of fun. So as you can see here, Gutsick Gibbon still doesn't understand genetic diversity. And guys, I think that's been pretty evident here today. She really does not understand genetic diversity. She's 0 for 3 on that argument, guys. She might as well tap out. She might as well tap out like she did the Y chromosome one too, and all the other videos. Poor. And here's the thing. It's not Erica's fault, because she's got egg on her face, because she's been shown to be wrong and shown to straw man and misrepresent. But she's just getting her arguments from other members of Team Dodgeball that got egg on their face. Oh, these pictures are too funny. But the ones she's parroting these arguments from are from critics who have decided to criticize our model by reading the papers we cite like this, blindfolded. Dr. Swamidass, take off the blindfold, or else you're going to keep making yourself look silly. Well, guys, this has been fun. Doki Doki says, and Standing says, not going to fall for his trap. Yeah, exactly. I forgot the orphan genes were in there too. See? Typical rescue device. De novo gene synthesis. It's circular, right? Hey, evolutionists, how do you explain orphan genes? Well, creationist, de novo gene synthesis. Oh, de novo gene synthesis. Why does that exist? Well, because we know orphan genes are there in the genome. We need a way to explain them. See, it's a big circle, right? Orphan genes exist because of de novo gene synthesis. De novo gene synthesis exists because of orphan genes. No, there's no number or series of mutations that are going to build that, which is like an orphan gene, something highly essential, taxonomically restricted to genomes of species. It's much easier to lose these orphan genes, to break something down, okay? What we're looking at in terms of the distribution of these orphan genes is diversification of the original created genotypes. That's it. That's it. No new ones have been gained, right? So, I mean, that's it really, guys. I think that was just icing on the cake, nail in the coffin. It goes to show that you can wait months for, so-called rebuttals, and it's nothing but dodging. But then, there we go. Young Earth Creation's coming after you. So anyways, guys, I'm glad that you all stuck with me. It's been a busy night, guys. We had a good 2.5-hour lecture from Sal. Faithful, Honest, and True says, Team Dodge, Duck, Dip, Dive, Dodge. That's right. Oh, this is too much fun. So yeah, guys, we're going on 2.5 hours. Taz, good to see you. Good to see you, brother. 3K on the way. That's true. Guys, we've never actually had a subscriber party here on SFT. I don't know why, but I'm going to tell you, when we hit that 3K subs, when we hit that 3K subscriber mark, we are having a 3,000 sub party, and it is going to be a heck of a party. We're going to make sure that is going to be a party to remember, a party that we'll never recover from. Praise is great stuff. Doki Doki Bible Club, $5 super sticker. Thank you so much. I appreciate it, Doki Doki. So guys, tell your friends, tell your family, share this video, share our channel, like, subscribe. Get us to 3,000 subscribers. Thanks for reminding everybody, Taz. So please, guys, share. We got to get these videos out to as many people as possible because we need the truth of creation. We need people everywhere to see this. They need to know that the Bible can be trusted, because a lot of times the science is a barrier to people hearing the gospel. It was for me. Once that barrier was removed, I was now willing and open to hear the gospel. The gospel being the saving grace of Jesus Christ. He's done the work. It's a free gift. But unfortunately, the science falsely so-called of fish to fisherman evolution and naturalism, abiogenesis, guys, it's not scientific. It's easily refuted. We have the stronger model. And we can be confident in the Bible. The Bible, the things we talked about today, these things did not have to be true. And as I said earlier, the evolutionary model is slowly becoming more and more like the biblical model. Because the Bible has predicted these things thousands of years ago. Thousands of years ago. So we can test the Bible to science. God did not have to give us all this scientific evidence, okay? By faith are we saved through grace. By faith we walk. And without faith, it's impossible to please God. But guess what? The Bible says that they are without excuse. And it's so true. Because the evidence is everywhere. It's undeniable. It's irrefutable. You have to be willingly ignorant. Okay? You have to be willingly ignorant to deny the truth that God has revealed to us. The consistency of God's word. The Bible says holy men spake as they were moved by the Holy Ghost. God's word, inspired by our Creator. The scientific evidence is overwhelming. He didn't have to give us all this evidence, and yet he did. He's an amazing creator. He wishes that all would come to repentance, and he leaves all this evidence for everybody to see. And still, people want to turn from all that evidence. Put the blindfold on. Ignore the data. So, that's about it. Just like Taz said, they are without excuse. And he says it's on. Here's the thing, Taz. That's right. It's actually becoming laughable. That's why this is so fun, guys. We're having a blast with this new series. And we're just getting started. Wednesday, Dr. Lyle will be here. Young Biblical Creation. November 30th, Dr. John McKay, PhD geologist. And all these evolutionist critics can do is cry. Look, the babies need their bottles. Diaper Dino. I mean, like I said at the beginning, congratulate. He's devolved. Dapper has turned into Diaper Dino. Anyways, guys, it's been fun. You guys are great. Glad to see there was an audience the whole time. We touched on a lot. This was information heavy, information packed. Now, guys, the content in this video won't be addressed. Our series will not be addressed. They've tapped out. That's it. That's it. They've tapped out. But we're having a blast. We have content forever. Doki, there you go. Doki doki. Amen. For this they willingly are ignorant of, that by the word of God the heavens were of old, and the earth standing out of the water and in the water. Guys, 2 Peter 3, a beautiful prophecy 2,000 years ago. Peter said in the last days there will be scoffers, denying three things. Three things. The creation, the flood, and the coming judgment. And are not those the three things? Are not those the three things that the skeptics and the scoffers deny? Right? The creation and the flood explains everything we see, and those are the two things they deny. And the Apostle Peter predicted this thousands of years ago. Amazing stuff. When I first read that, I was blown away, guys. Fulfilled prophecy. Fulfilled prophecy. So, guys, thanks. Yeah. Gavin says 19 watching. Yeah, we've been going strong for 3 hours, and we've had a good audience, even at 5 in the morning. So Doki Doki Bible Club, Xavier, Praise, Gavin, Sister Joe, Taz, Faithful Honest, Luca. Anyways, guys, SFT is out. You guys have been fun as usual. Stay tuned. We got lots more goodies in the coming weeks, especially this week. I think we've got something scheduled almost every single day. For more on this topic too, guys, like I said, SFT versus Swamidass on genetic diversity, a must watch, I'm telling you. So, guys, I'm going to call it a night. It's been fun. We've had a busy night. I think almost 6 hours of streaming. So anybody who's new to the channel or people who just got here, please go watch the wonderful lecture with Sal, and make sure to watch this right from the beginning, because Team Dodgeball exposed again. Everybody, SFT is out. God bless.
For all those who appreciate the work that we're doing here on Standing for Truth,